Hello my friends, and welcome back to the YouCanDo TV channel. In this video, we'll explore impressive embankment and breakwater construction projects around the world. The construction process of the Accropodes Dam in Cerbere has been a significant undertaking. Given the challenging coastal environment and the need to protect the town from powerful sea storms, the design of the Cerbere Dam is based on the use of Accropodes, a type of concrete block commonly used along the Mediterranean coast. However, the new generation of Accropodes being used in Cerbere allows for easier and faster installation. The construction process involves collecting scattered rocks and materials from the sea, sorting them according to different sizes, and reintegrating them into the dam. Both terrestrial and maritime rock excavation techniques are employed to anchor the future Accropodes and the dam to the seabed. Anchoring depths range from 2 to 8 meters, with the process taking approximately 2 months. At the prefabrication site, activity is at its peak. The concrete plant produces 150 cubic meters of concrete per day, and around 15 to 20 workers are engaged in the prefabrication process. The Accropodes used in the project are the latest generation, weighing 5 tons each and measuring approximately 3 meters in height and width. They have been shaped and welded by the Tunisian company Suez Canal, who are specialists in this field. This marks the first time that the latest generation of Accropodes has been manufactured and installed in France, making the Cerbere project a pioneering endeavor. Accropodes are produced here. When the concrete reaches the required hardness, the mold is removed. Accropodes blocks will be transported to the dump. After the Accropodes have undergone a drying period of 21 days, they are ready to be transported and installed on the structure of the Cerbere Dam. To handle the heavy Accropodes, a powerful 200-ton crane is utilized. This crane is not only capable of lifting the massive blocks, but also equipped with GPS guidance technology to ensure precise positioning. The GPS system assists the crane operator in accurately placing the Accropodes according to a predefined plan, ensuring that they are aligned correctly and fit seamlessly into the overall structure of the dam. However, the installation process requires more than just the crane operator's expertise. Divers play a vital role in assisting the crane operator during the placement of the Accropodes. The divers work in coordination with the crane operator, providing visual guidance and ensuring that the blocks are positioned accurately in accordance with the predetermined plan. The majority of materials used in the construction, including rocks and aggregates, are sourced from the remnants of the old dam. However, additional rock supplies are obtained from quarries to meet the required quantities. In total, approximately 32,000 cubic meters of rock have been dredged and placed, with the rocky blocks weighing between 1 and 10 tons. A combination of maritime and terrestrial transport methods have been employed to transport and position a total of 70,162 Accropodes blocks and 400 grooved cubic blocks. During the construction of the Cerbere Dam, a significant amount of concrete was used for the crown wall and quays, totaling 3,000 cubic meters. This substantial quantity of concrete was necessary to ensure the structural integrity and stability of these key components of the dam. The crown wall serves as a protective barrier against the force of the sea, while the quays provide additional support and functionality for the overall infrastructure. Once the main construction phases are completed, the focus shifts to the final stage of the ongoing project. This phase involves the precise placement of the remaining Accropodes blocks using specialized self-propelled cranes. These cranes are meticulously operated to ensure accurate alignment and positioning of the blocks. The purpose of these final Accropodes is to securely connect and integrate the existing Accropodes with the crown wall. The completed Cerbere dam has a length of 110 meters, a height of 4 meters, a 6.20 meter wide promenade, and a depth of 12 meters. The production of wave-dissipating blocks, commonly known as tetrapods, involves several stages to ensure the manufacturing of high-quality and durable structures that effectively dissipate wave energy. This section shows an overview of the production process. Assembly of 3 shape-forming pieces. In this step, 3 shape-forming pieces are brought together and assembled in a specific configuration to create the mold for the tetrapod. These pieces are designed to give the tetrapod its characteristic shape. Pouring concrete mix. Once the shape-forming pieces are assembled, a concrete mix is prepared according to the required specifications. The concrete mix is typically a combination of cement, aggregates, such as sand and gravel, water, and sometimes additives. The mix is carefully poured into the mold formed by the shape-forming pieces. Compacting of the concrete mix with a vibrator. To ensure the concrete mix fills the mold uniformly and eliminates any air pockets or voids, a vibrator is used. The vibrator is inserted into the concrete mix, and its vibrations help to compact the mix, improving its density and strength. The compaction process also helps to remove any trapped air bubbles. All connections are tight. Leakage of the mixture is excluded. After the concrete mix is compacted, the tetrapod is carefully inspected to ensure all connections are tight. Any potential leaks in the concrete mixture are checked and addressed, ensuring the tetrapod is properly formed and structurally sound. Curing and demolding. After pouring and vibrating, the filled molds are left undisturbed to allow the concrete to cure and gain strength. The curing process is crucial for the development of the tetrapod's durability and structural integrity. It typically takes several days or weeks, depending on the specific concrete mix and curing conditions. Once the tetrapods have reached sufficient strength, the molds are dismantled and the blocks are demolded. Careful handling is necessary to prevent any damage to the newly formed tetrapods during this stage. Quality control and finishing. Each tetrapod is inspected for any defects or imperfections. Quality control measures ensure that the finished blocks meet the required standards and specifications. Any necessary repairs or adjustments are made at this stage. The tetrapods may also undergo surface treatments, such as sandblasting, to improve their resistance to erosion and enhance their appearance. Caisson technology has revolutionized the construction of port infrastructures. It offers a wide range of design possibilities, making it suitable for various marine structures such as vertical quays, docks, sea containers, offshore foundations, mooring dolphins, and offshore stations. This versatility allows for innovative solutions and even the simultaneous construction of docks and quays, providing a mixed approach compared to traditional breakwater options. Essentially, a caisson is a concrete and steel structure that provides rigidity and stability to marine structures. Acciona Infrastructure, a leader in the field with over 100 years of experience, has built the largest reinforced concrete caisson in the world, measuring 66.5 meters long, 24.6 meters wide, and 34 meters high. The first step in constructing a caisson is the preparation of a reinforced concrete floor. A raft with steel rods is introduced to reinforce the floor of the caisson building dock. This floor serves as the foundation for the entire structure. Once the floor is in place, the next step is to lower the structure that suspends the formwork. The formwork, which is a temporary mold or casing, is then coupled up as it slides down. This formwork will contain the concrete during the pouring process. With the formwork in position, the concrete is poured into the caisson. It is important to ensure the concrete is properly mixed and of high quality to ensure the strength and durability of the caisson. The concrete is left to set and harden. Once the caisson is completed, the formwork is removed, leaving the caisson ready for further construction or deployment. To anchor and support the caissons, rock fill foundations are often used. Barges are employed to transport the rocks and load them onto the foundation where the caissons will be anchored. Finally, the caissons are anchored and stabilized by ballasting themselves. This is done by adjusting the weight and balance of the caissons, ensuring they remain stable and in position. The construction process of a caisson offers advantages such as reduced construction time, enhanced worker safety, lower environmental impact, and the flexibility to manufacture and join caissons in different locations before floating them to their final position. This process has revolutionized the construction of port infrastructures, providing a versatile and efficient method for building marine structures. The construction of the Quay Wall at the new Tema port facility in MPS, Marine Port Services, utilizes caissons cast on land method. This construction technique involves the creation and installation of large concrete structures called caissons to form the Quay Wall. To begin the process, a trench is dredged in the seabed at a depth of 19 meters. This trench serves as the foundation for the caissons. The caissons themselves are prefabricated on land, with each unit requiring an impressive 1,000 cubic meters of concrete. These massive structures weigh around 2,600 tons each. Once the caissons are completed on land, they are transported onto a floating dock. To begin the transfer process, the completed caissons are carefully positioned near the edge of the floating dock. The inflatable airbags, made of robust and durable materials, are strategically placed beneath the caissons. These airbags are designed to be strong enough to support the weight of the caissons, while providing a low-friction surface for their movement. Once the airbags are in position, they are inflated with compressed air. As the airbags expand and inflate, they create a cushion of air between themselves and the dock's surface. This air cushion reduces the friction between the caissons and the dock, making it easier to roll the caissons onto the floating dock. Using specialized equipment, such as hydraulic jacks or winches, the caissons are gradually rolled onto the airbags. The smooth, controlled movement is achieved by carefully coordinating the forces applied to each caisson. This process ensures that the caissons maintain their stability and alignment during the transfer. As the caissons roll onto the airbags, they glide smoothly along the surface of the dock. The inflated airbags provide a cushioned pathway, minimizing any potential impact or damage to the caissons. This method is especially useful when dealing with large and heavy structures like the 2,600-ton caissons used in the construction of the Quay Wall at MPS. At this point, the floating dock is intentionally sunk, causing the caissons to float. Tugs then maneuver the caissons into their designated positions along the Quay Wall. To secure them in place, the caissons are deliberately filled with water, causing them to sink and settle into the seabed. To complete the construction, the caissons are filled with sand, and the deck of the quay is cast on top. This final step ensures a stable and functional quay wall that can accommodate various maritime activities. In the manufacturing process of the concrete floating pontoons for the Urban Rigger 2.0 project, the fabrication of molds played a crucial role in achieving the desired shape and dimensions of the pontoons. The molds were constructed using a combination of rebar and steel frames to provide strength and stability during the casting process. The steel frames were constructed using sturdy steel bars or beams that were welded together to create the desired shape. The rebar was strategically placed within the steel frames, forming a lattice-like structure. The rebar was secured to the steel frames using wire or metal ties to ensure proper alignment and stability. With the molds in place and the concrete mix prepared, the pouring process began. The concrete mixture was carefully and evenly poured into the molds, taking care to prevent the formation of air pockets or voids. This was done using a concrete pump to facilitate a smooth and controlled flow. The bottom deck of each pontoon was constructed with a thickness of 25 centimeters, providing a sturdy foundation for the entire structure. The area covered by the bottom deck measured 220 square meters per pontoon, offering ample space for various purposes. The external walls of the pontoons were built with a thickness of 20 centimeters, ensuring structural integrity and resistance to external forces such as waves and weather conditions. The internal walls, on the other hand, had a slightly thinner thickness of 15 centimeters, which still provided sufficient strength and durability for the internal spaces. To complete the pontoon structure, a deck with a thickness of 20 centimeters was added on top. This deck not only served as a walking surface, but also contributed to the overall stability and load-bearing capacity of the pontoons. The height of the pontoons varied, with the lower side measuring 3.2 meters and the upper side reaching 3.62 meters. This design allowed for a multi-level structure, accommodating different functionalities and providing a diverse living or working environment. Once the manufacturing process was completed on land, the final pontoon was transported and set sail to Denmark, where it would be utilized in the Urban Rigger 2.0 project. The hull of each pontoon, excluding the deck, weighed 250 tons, while the total weight of the hull, including the deck, amounted to 330 tons. The construction of the protective belt for the new eco-district in Monaco began in the port of Marseille, where meticulous planning and precise execution were crucial. 18 reinforced concrete caissons, each weighing a staggering 10,000 tons, were manufactured to serve as the foundation for the offshore extension. The manufacturing process involved continuous casting, with the caissons being poured with reinforced concrete into large molds. These molds were placed on a specially constructed floating metal structure known as the Marco Polo. This continuous casting method allowed for efficient and continuous production of the caissons. Once the concrete was poured, the caissons were left to cure and gain strength. After the curing process, the caissons were prepared for their installation. They were carefully positioned and floated on the water surface. This floating stage allowed for the caissons to be maneuvered into the desired locations before being sunk. To sink the caissons, a controlled flooding technique was employed. The caissons were designed with specific compartments that could be filled with water. As the compartments were gradually flooded, the weight of the caissons increased, causing them to gradually descend into the water. The sinking process was carefully controlled to ensure that the caissons settled firmly on the seabed. This method allowed for precise positioning and alignment of the caissons, ensuring a stable foundation for the offshore extension. The weight of the caissons, along with their reinforced structure, provided the necessary stability to withstand the forces exerted by the sea. As the caissons gradually sank into the water, they formed a protective belt surrounding the construction area. This belt served as a barrier to protect the future eco-district from the sea's forces, while providing a stable base for further construction activities. The erection of the North Channel Bridge marks a significant milestone in the ambitious North Channel Bridge replacement project, undertaken by the esteemed Can-Am Group. Situated in Cornwall, Ontario, this construction endeavor aims to replace an aging highway bridge that spans the majestic St. Lawrence Seaway. The erection process of the North Channel Bridge involves intricate engineering, meticulous planning, and precise execution. With the expertise and experience of the Can-Am Group, this monumental task is being carried out with utmost care and precision. The bridge, designed to withstand the test of time and support heavy traffic loads, will provide a vital transportation link between two regions, enhancing connectivity and fostering economic growth. As the construction team meticulously follows the project timeline, the erection of the North Channel Bridge commences with the assembly of its components. The massive steel beams, carefully fabricated off-site, are transported to the construction site. Crane operators skillfully position the beams into place, aligning them with accuracy, ensuring structural integrity, and adhering to rigorous safety standards. The erection process is a marvel to behold, as the bridge gradually takes shape, spanning the vast expanse of the St. Lawrence Seaway. The onlookers are captivated by the synchronized ballet of machinery as construction workers skillfully maneuver the steel beams into position, securing them with precision welding and connecting various sections of the bridge. As the last beam is put into place, a sense of accomplishment permeates the air. The erection of the North Channel Bridge symbolizes the culmination of collective effort, dedication, and expertise. It stands as a testament to the vision and commitment of the Can-Am Group, who have successfully delivered a vital infrastructure project that will serve the community for generations to come. In Quay Wall, Vietnam, several projects are being implemented to manage coastal erosion, prevent landslides along the coastline, and restore mangrove forests to cope with climate change and improve livelihoods for coastal communities. One of these projects is the construction of the Mui Ran Coastal Protection Embankment in Bien. Construction process of D300 reinforced concrete pipe pile at Mui Ran Embankment, in Bien, Quay Wall is quite simple. The piles were attached to the excavator's bucket using chains. The piles are then transported to the designated locations for installation. The operator of the excavator uses the bucket to drive the piles deep into the seabed. This process requires precision and high technical expertise to ensure the piles are securely and stably driven into place. The Mui Ran Coastal Protection Embankment project in Bien spans a length of 5,000 meters and is currently being implemented. Through pile driving and embankment construction, this project aims to protect the coastline from erosion and provide favorable conditions for the livelihoods and lives of people in the area. The process of constructing BTCT D300 pipe piles is an essential part of building the coastal protection embankment, contributing to the safety and sustainability of the coastal infrastructure and environment in the region. The construction of the embankment was a significant phase in the Offshore extension project in Monaco. The embankment played a crucial role in providing additional stability and support to the platform and the overall infrastructure. The construction process began with the transportation of quarry materials to the construction site. Specialized boats equipped with conveyors passed above the Caisson belt, efficiently delivering the quarry materials to the designated location. This innovative approach minimized the logistical challenges and facilitated the distribution of materials. Various earthwork workshops were then responsible for carefully distributing the quarry materials onto the platform. The materials, typically measuring 0 by 50 millimeters, were strategically placed, layer by layer, to create a strong and solid embankment. Each layer was compacted to ensure optimal density and stability. The embankment served multiple purposes. Firstly, it provided a robust foundation for the subsequent construction activities, ensuring that the platform had a stable base. Secondly, it acted as a protective barrier against the forces of the sea, shielding the eco-district from potential erosion and wave impact.
Gomaco is a reputable company that specializes in intelligent construction solutions. They are known for their expertise in producing high-quality prefabricated concrete elements. The production process at here starts with the verification of the molds by their diligent quality control team. They meticulously inspect the molds to ensure they meet the required specifications and are free from any defects or flaws. Once the molds pass the verification stage, they undergo cleaning and lubrication. This step is essential to ensure that the molds are free from any debris or residue that could affect the surface of the concrete elements. Lubricating the molds helps in achieving a smooth demolding process, preventing any potential sticking or damage to the concrete. The next step involves positioning the embedded components on the molds. These components, such as reinforcement bars or inserts, are carefully placed according to the design requirements. The precise placement of these components is crucial to ensure that the final concrete elements possess the necessary structural integrity and functionality. After the embedded components are in place, the construction of the reinforcement cage takes place. Skilled workers assemble steel bars and other reinforcement materials within the molds. This reinforcement cage provides the required strength and stability to the final concrete elements. Attention to detail is crucial during this step to ensure the proper positioning and secure attachment of the reinforcement cage. Once the reinforcement cage is complete, the molds are ready for the concrete pouring process. The team at Gomaco expertly mixes high-quality concrete and pours it into the molds. They ensure that the concrete completely fills the desired shape and form. Proper compaction techniques are employed to eliminate any potential air pockets or voids within the concrete, ensuring the strength and durability of the final elements. After pouring, the concrete is left to cure and gain sufficient strength. Once the curing process is complete, the time for demolding arrives. The molds are carefully removed to avoid any damage to the newly formed concrete elements. Skilled workers handle this step with precision to preserve the shape and integrity of the elements. Finally, before the concrete elements are considered ready for use, a thorough inspection is conducted to verify their dimensions. Measurements are taken to ensure that the elements meet the specified requirements in terms of length, width, height, and other relevant parameters. Any deviations are promptly addressed to ensure that the elements meet the necessary standards. Stress-light precast concrete is created by fabricating molds for individual concrete units and then filling these molds with a blend of GGBS cement mixed on-site. This process reduces house construction to a series of separate concrete pieces. One of the key benefits of precast construction is the ability to achieve precise finishes and aesthetics for each concrete unit. By utilizing advanced techniques, a higher quality product with greater accuracy can be achieved. Before reaching the construction site, every precast piece undergoes thorough quality control checks to ensure consistent and high quality standards. Designed on-site and manufactured in Stressleit's factory, the precast concrete units are then delivered directly to the building site and swiftly installed. A precast frame package typically includes columns, beams, floors, wall panels, stairs, landings, and balconies. With a significant portion of the house being precast, the overall construction time is significantly reduced. In fact, it is possible to witness the construction of a 3-story house up to roof level within just 4 on-site days. Stresslight also offers a wide range of precast composite floor systems that can accommodate spans of up to 10 meters. These systems are highly adaptable and quick to install on-site, reducing the need for additional columns or joints. Immediate safe access for all trades on-site is ensured, and precast stairs are also manufactured in Stressleit's factory, facilitating quick and easy installation. This not only contributes to a safer working environment, but also provides enhanced fire resistance, durability, and strength compared to traditional concrete block construction methods. Precast concrete offers superior acoustic insulation between floors and rooms compared to other materials. Test figures demonstrate that a 150 mm concrete floor can achieve airborne sound insulation as high as 50 decibels. The speed and simplicity of design and installation also allow for layout flexibility, enabling clients to make changes to internal walls or replace load-bearing walls with beams, depending on their design preferences. Precast methods enable the construction of suspended balconies or cantilevers, opening up greater design possibilities. The quick internal construction method allows trades to efficiently plan and execute services such as electricity, heating, and plumbing, preventing scattered pipes and conduits. This leads to better maintenance and management of the home in the long run. Furthermore, precast construction is environmentally friendly. The materials used in precast slabs are sourced close to Stressleit's factory, reducing transport distances and the use of fossil fuels. Additionally, precast construction reduces overall concrete usage in a house by up to 20%, while on-site construction waste is almost eliminated. The tilt-up construction process starts with the formwork, often made of wood or steel, is set up on the construction site floor. The formwork creates the shape and structure of the tilt-up wall panels. It is reinforced with steel rebar for added strength. Concrete placement and panel casting. Once the formwork is in place, the concrete mixture is poured into the forms. The concrete is typically a high-strength mix designed for tilt-up construction. Any architectural finishes or textures can be applied to the concrete surface before it cures. Curing and panel preparation. The concrete panels are allowed to cure and gain sufficient strength. During this time, any necessary lifting inserts or anchor points are embedded in the panels to facilitate the lifting process. Panel lifting is the critical step in the tilt-up construction process that involves carefully raising and positioning the concrete wall panels into their vertical position. It requires specialized equipment, such as cranes or forklifts, and a well-coordinated effort by the construction team. Before the lifting process begins, a metal structure referred to as a lifting and support mechanism is attached to the top edge of each panel. This structure is made of steel and is securely connected to the embedded steel plates, or embeds, that were placed in the panels during the casting phase. The lifting apparatus is designed to distribute the weight of the panel evenly and ensure a safe and controlled lift. Once the lifting mechanism is in place, the construction team operates the crane or forklift to carefully lift the panel off the ground. The lifting process requires precision and coordination to avoid any damage to the panel or injury to the workers involved. The panel is lifted vertically, gradually and smoothly, guided by the lifting apparatus. As the panel is lifted, the construction team ensures that it remains stable and balanced. They use additional bracing and support systems to keep the panel in position during the lifting process. Once the panel is clear of the ground, the crane or forklift carefully maneuvers it into its final position, aligning it with the previously erected panels. Once the panel is in place, it is secured to the adjacent panels, and any necessary adjustments are made to ensure proper alignment and fit. The process is repeated for each panel until all the walls of the structure are erected. Metal structure elevation. As the concrete panels are lifted, a metal structure, typically made of steel, is erected to support the panels and provide structural stability to the building. This metal structure serves as the framework onto which the panels will be attached. Panel placement and connection. The lifted panels are guided into their final position and secured to the metal structure. Adjacent panels are connected using various methods, such as welded or bolted connections, to ensure structural integrity. Roofing installation. Once the walls are in place, the roofing system is installed. In some cases, a KR18 system, which is a type of metal roofing system, may be used. The roofing system is designed to provide protection against the elements and complete the building envelope. Finishing touches. After the walls and roofing are in place, any necessary finishing touches are applied. This may include painting the walls, applying exterior cladding or siding, installing windows and doors, and completing any interior construction activities. Earthworks and asphalt. Finally, any remaining earthworks, such as grading and landscaping, are carried out. If required, asphalt or other paving materials may be installed for parking areas or driveways. Building a wooden house, such as the Mutter-kind house in Niedergrunstedt near Weimar, is an excellent example of eco-friendly and modern construction. This particular house, operated by the Dr. Georg Haar Foundation, was designed to provide a healthy living environment for 8 mothers and their children. The construction process began with careful consideration of the local context and the surrounding village's traditional gabled roof architecture. The architects Tectum Hill, Cobalt Architekten, took inspiration from this typology and reinterpreted it in a contemporary way. By offsetting the building volumes, they created terraces, gardens, and courtyards with high-quality outdoor spaces. To ensure energy efficiency and sustainability, the exterior design of the wooden house was consistently translated into the construction. The outer appearance features rough-sawn larch cladding with a natural color, blending harmoniously with the surroundings. The primary load-bearing elements were constructed using prefabricated solid wood panels with thicknesses ranging from 8.5 to 15 centimeters, resulting in a fast construction process of only 3 working days. Inside the house, the natural beauty of the wood was preserved by leaving the surfaces of the solid wood walls visible and applying a whitewash, showcasing the simplicity and craftsmanship of the raw wooden structure. The house achieved a low energy standard of KfW 70 by incorporating 20 centimeters of insulation, a ventilated wooden facade, south and west facing windows, and connections to a solar thermal system and district heating network. The interior of the Mutter-kind house was designed to create a welcoming and healthy living environment. The pleasant tactile qualities of wood were utilized throughout the house, including the custom-built furniture. In an effort to reduce waste, leftover pieces of solid wood from doors and window cutouts were repurposed as integrated furniture elements. The architects paid attention to every detail, even concealing rainwater pipes, gutters, and flashing behind the cladding to maintain the simplicity of the building geometry. The communal areas feature a flat roof with skylights, floor-to-ceiling windows, and a direct connection to the outdoors, distinguishing them from the more intimate individual spaces. Horizontal larch cladding emphasizes this differentiation and adds an architectural touch to the facade. By combining ecological principles with modern design, the Mutter-kind house stands as a testament to the possibilities of wooden construction. It provides a healthy and sustainable living space while integrating seamlessly into the local context. The architects, Christiane Hill and Roberto Cobalt, successfully created a modern wooden house that is both aesthetically pleasing and environmentally conscious. DIY builder Christ Morse shows how he stacked and reinforced his ICF basement walls. Start by pouring the footings as the foundation for the walls. Use ICF blocks to stack the walls. Ensure that the blocks are of the appropriate size and type for your specific project. The blocks should be chosen according to the desired wall thickness and insulation requirements, ensuring they fit together securely and provide the necessary structural integrity. If your project involves constructing a circular structure, like the circular tower in the Hilltop House, use special bill block radius blocks designed for creating curved walls. As you stack the ICF blocks, add horizontal rebar reinforcement according to the specifications provided by your engineer. The horizontal rebar helps strengthen the walls. After stacking all the blocks for the basement walls, Brace the walls and install scaffolding to prepare for the concrete pour. The scaffolding provides support and stability during the pouring process. Utilize the scaffolding to install vertical rebar reinforcement. This involves placing vertical rebar rods at specified intervals between the stacked ICF blocks. The vertical rebar enhances the structural integrity of the walls. Ensure that the horizontal rebar runs on the inside and outside of the walls, overlapping or alternating every course of blocks. This helps distribute the load and reinforce the entire wall system. Trim the ICF blocks as necessary to accommodate additional components or features. For example, if you plan to pour an 8-inch build deck on top of the walls, modify the top layer of the blocks to accommodate it. Use appropriate tools like a table saw or a sawzall to make precise cuts. Remove excess material from the modified blocks to create space for the build deck, but be careful to maintain the necessary attachment points and thickness of the webbing for structural stability. Repeat the stacking, reinforcing, and trimming process for all the required courses of blocks. Ensure that you follow the engineering specifications and local building codes throughout the construction process. In the case mentioned, the basement walls are stacked to a height of 9 feet 4 inches, with the 8th course trimmed to 4 inches to accommodate the build deck. Remember to consult with professionals, such as engineers and contractors, for specific guidance and to ensure compliance with local building regulations. The construction process of stress-light precast concrete tank begins in the factory, where the precast concrete panels are produced. These panels are manufactured using high-quality concrete and reinforced with steel bars to provide strength and structural integrity. The concrete mix is carefully designed to meet the specific requirements of BS 8007 to 1987, a British standard for the design of concrete structures for retaining aqueous liquids. To ensure a superior finish and enhanced longevity, the panels undergo a rigorous vibration process during production. This process helps to remove air bubbles and compact the concrete, resulting in a smooth and robust surface. Working in collaboration with leading building contractors, Stress-Lite delivers cost-effective and high-quality tanks using the precast concrete manufacturing process. This approach offers numerous advantages, including faster installation and reduced on-site labor requirements. The construction of the tanks typically takes around 2 to 3 weeks to complete, after which a water test is conducted to ensure their integrity and functionality. This test confirms that the tanks are watertight and ready for use. One notable aspect of Stress-Lite tanks is their flexibility in design. Each tank can be custom designed to accommodate specific pipework and equipment requirements based on customer needs. This versatility allows for seamless integration with existing infrastructure and ensures a tailored solution for individual projects. Importantly, Stress-Lite tanks are renowned for their low maintenance requirements. The quality of the precast concrete and the precision manufacturing process contribute to an extended lifespan compared to alternative storage facilities. This durability and longevity makes Stress-Lite tanks a reliable and cost-effective choice for storing various liquids. In addition to the tank structure, Stress-Lite has developed a precast system for the roof and supporting columns. This comprehensive approach provides a complete solution for tank manufacture, ensuring consistency and compatibility across all components.
Crushed rock is an essential material of construction, leveling, and road construction works. In this section, we will visit the US-based Rogers Group's Whites Creek Quarry to explore the manufacturing process of crushed rock. The first phase of the process is drilling and blasting. A blaster lays out a specific pattern of shots to ensure the correct amount of explosive force is distributed evenly in the holes. This pattern helps to create safe blasts and reduce vibration. A subcontract drilling company is then called in to drill the holes, which usually takes around 2 days. After drilling, the holes are loaded with explosives and connected with electronic blasting caps. The electronic blasting caps enable precise control over the timing of the shots, ensuring each hole goes off milliseconds apart, minimizing vibration and improving the overall effectiveness of the blasting. The next step is loading and hauling the material from the muck pile to the primary crushing station. This is accomplished using large haul trucks with a capacity of 260 tons. The trucks are loaded either with a front-end pit loader or a track loader. They transport the material approximately 1,500 feet to the primary crusher. Crushing and screening are crucial stages in the production of crushed rock. The process is broken down into several steps. The primary crushing begins with a 42 by 48 jaw crusher. The material from the haul trucks is dumped into a primary crushing hopper. A grizzly feeder pre-screens the rock, allowing only material larger than 5 inches to enter the primary crusher. The jaw crusher breaks down the rock from a size of 3 to 4 feet to 8 to 12 inches. The crushed material is then conveyed out of the pit and into a surge pile. The surge pile acts as a buffer, ensuring the primary crusher operates efficiently, regardless of the processing plant's workload. It also serves as a storage area for future processing. From the surge pile, the material undergoes secondary processing. Conveyors transport the material out of the surge pile to a scalping screen, which separates the rock into different sizes. Anything larger than 3 inches is sent to a 5.5 cone crusher, which further reduces the size of the rock. The material is then sent to an April 20th triple-deck sizing screen, where it is sorted into different sizes. Anything larger than 1 inch goes to the tertiary crusher, while smaller material continues to the processing line or wash plant. The trucks are directed to appropriate piles for loading. A Volvo 220 front-end loader fills the trucks with the desired material. Typically, 3 scoops of material are sufficient to fill 2 to 3 ton loads. The Whites Creek Quarry produces various products to meet different construction needs. The primary product is number 57 stone, also known as 3/4, which is primarily used in concrete. Other products include crusher run, number 7 stone, 1/2 inch, for asphalt plants, riprap for erosion control, and number 1 stone for erosion control. The leveling process for the Istanbul Airport project was an enormous undertaking that played a critical role in transforming the sprawling site into one of the world's largest airports. Spanning a staggering area of approximately 76.5 million square meters, the project aimed to create a state-of-the-art airport facility capable of meeting the growing demands of the region. The leveling process involved extensive earthwork and grading activities, which required careful planning, advanced machinery, and skilled operators to achieve a uniform and suitable ground surface for subsequent construction phases. The site itself presented a host of challenges, including uneven topography and varying soil conditions. The leveling process had to address these obstacles and create a consistent ground level that could accommodate the construction of runways, terminals, and other vital airport infrastructure. To achieve this, a comprehensive approach was adopted, employing advanced surveying techniques and cutting-edge machinery to ensure precision, efficiency, and optimal results. The first phase of the leveling process involved site clearance, which entailed the removal of vegetation, rocks, and other obstructions. This meticulous clearance was necessary to provide a clear and unencumbered canvas for the subsequent earth-moving activities. Additionally, it facilitated the identification and protection of environmentally sensitive areas within the project site. Once the site was cleared, the leveling process progressed to the excavation phase. Vast quantities of soil needed to be moved to create a balanced cut and fill situation, where excess soil from higher areas was redistributed to fill lower areas. This approach aimed to minimize elevation variations across the site and establish a consistent ground level, crucial for the smooth operation of the airport. The excavation phase required the deployment of an extensive fleet of earth-moving equipment, including heavy-duty bulldozers, excavators, and graders. These formidable machines worked in harmony, orchestrated by skilled operators, to cut, shape, and redistribute the earth according to the design specifications. Their sheer power and precision allowed for the removal of millions of cubic meters of soil, which was transported and utilized in the leveling process. To ensure accuracy and adherence to design specifications during the leveling process, advanced surveying techniques were employed. Global Navigation Satellite Systems, GNSS, and total station instruments were utilized to establish precise control points and monitor elevation changes throughout the site. This real-time data was essential for maintaining the desired slope and gradient, enabling proper drainage and alignment of the airport infrastructure. The numbers associated with the leveling process for the Istanbul Airport project are truly staggering. It is estimated that approximately 85 million cubic meters of earth were excavated and transported during the course of the project. To put this colossal figure into perspective, imagine filling about 34,000 Olympic-sized swimming pools with the excavated soil. Such a tremendous volume of earth-moving operations showcases the magnitude and complexity of the leveling process. The challenges faced during the leveling process were further amplified by the sheer size and intricacy of the project site. Considerations such as the presence of underground utilities, environmental impacts, and the need to minimize disruption to surrounding areas had to be meticulously addressed. Environmental measures were implemented to mitigate the potential impact of construction activities, including the implementation of dust control measures and sedimentation management strategies. The successful completion of the leveling process was a pivotal milestone as it laid the foundation for subsequent construction activities. Once the site was expertly leveled and prepared, the construction of the airport's runways, taxiways, terminal buildings, and other critical infrastructure components could commence. The Istanbul Airport project, upon completion, aimed to boast an impressive 6 runways, multiple terminals, and a staggering capacity to handle around 200 million passengers annually. The Istanbul Airport project is an immense undertaking that involves extensive construction across various components of the airport. One remarkable aspect of this project is the sheer volume of construction required, particularly in terms of concrete production. The total construction volume for the entire project is estimated to be significant, with an astounding 7 million cubic meters of concrete being produced. This staggering figure highlights the scale and magnitude of the construction efforts undertaken to bring the airport to fruition. To put this into perspective, it can be compared to the construction of the famous Empire State Building in New York City. The Empire State Building, an iconic skyscraper, is approximately 443.2 meters in height and was built using around 200,000 cubic meters of concrete. In other words, the concrete production for the Istanbul Airport project is equivalent to the concrete volume used in constructing 35 Empire State Buildings. Such a massive amount of concrete production underscores the extensive infrastructure development required for the airport. It encompasses not only the terminal building and air traffic control tower, but also the construction of runways, taxiways, aprons, parking facilities, and various support structures. The air traffic control tower will serve as the central command center for managing aircraft movements and ensuring safe operations within the airport's airspace. It will be equipped with advanced communication and surveillance systems to facilitate efficient air traffic control. The tower's design will incorporate the latest technologies and conform to international standards for air traffic management. Adjacent to the air traffic control tower, the terminal building is also underway. The terminal building, designed to accommodate the growing demand for air travel, spans an impressive area. With a total floor space of approximately 1.3 million square meters, it will feature multiple levels, including arrivals, departures, and transit areas. The terminal is expected to have a capacity of handling around 90 million passengers annually, providing a seamless travel experience with modern amenities, retail spaces, and dining options. Furthermore, the Istanbul Airport project has prioritized sustainability and environmental considerations. The terminal building will feature energy-efficient systems and incorporate renewable energy sources to reduce its carbon footprint. The project aims to achieve Leadership in Energy and Environmental Design certification, emphasizing its commitment to eco-friendly practices. One of the primary objectives of the road construction process is to create a smooth and safe transportation route for passengers, employees, and cargo vehicles. Extensive surveys and analyses are conducted to determine the most suitable road alignments, considering factors such as traffic flow, connectivity to major highways, and environmental considerations. The Istanbul Airport project aims to construct several main access roads leading to the airport, along with secondary roads within the airport premises to facilitate internal transportation. These roads are designed to accommodate high volumes of traffic, including heavy-duty vehicles, and provide convenient connectivity to nearby urban areas. During the construction process, various tasks are undertaken, including land clearing, earthwork, grading, drainage system installation, and pavement construction. Advanced machinery and equipment, such as excavators, bulldozers, graders, and pavers, are utilized to carry out these tasks efficiently and effectively. The Istanbul Airport project includes the construction of approximately 50 kilometers of main access roads, comprising multiple lanes in each direction to ensure efficient traffic flow. Additionally, around 30 kilometers of secondary roads are planned within the airport premises to connect various terminals, parking facilities, and service areas. Asphalt paving works have commenced on runway 1 of Istanbul New Airport, which spans 3,750 meters in length and 60 meters in width. This milestone marks a significant step in the realization of the airport project with utilizing modern techniques and equipment. Moreover, ensuring the safety of the roads is of utmost importance. Road markings, signage, lighting, and barriers are strategically installed to guide drivers and enhance visibility, especially during nighttime or adverse weather conditions. Additionally, safety measures like guardrails and pedestrian walkways are implemented to protect road users. The local 528 cement masons and plasterers in Seattle recently undertook an impressive high-rise concrete pour that showcased their expertise and the scale of their work. With a deck spanning approximately 10,000 square feet, this pour was no small task. A high-rise concrete pour is a significant milestone in the construction of a building, as it lays the foundation for the entire structure. The concrete acts as the structural support, providing stability and strength to the building. Prior to the pour, the construction site was meticulously prepared. The necessary framework and reinforcement were installed to support the weight of the concrete. Once the preparations were complete, the concrete trucks began arriving one by one. These massive vehicles carried the freshly mixed concrete. The cement masons worked in unison, directing the flow of concrete and ensuring it was evenly spread across the deck. The cement masons utilized a range of specialized tools to manipulate and refine the surface of the poured concrete, ensuring a level and uniform finish. These tools are designed to facilitate the smoothing and shaping of the concrete, resulting in a durable and aesthetically pleasing surface. Trowels are one of the primary tools used by cement masons during the finishing process. They come in various sizes and shapes, including hand trowels and power trowels. Hand trowels have a flat metal blade attached to a handle, allowing masons to manually smooth the surface of the concrete. Power trowels, on the other hand, are mechanical tools equipped with rotating blades that efficiently cover larger areas of concrete. By running the trowel over the concrete, the masons are able to eliminate imperfections and create a smooth, polished appearance. Floats are another essential tool in the cement mason's arsenal. Floats have a flat, rectangular, or square surface made of wood and aluminum. They are used to level and smooth the concrete surface by eliminating high spots and filling in low areas. Floats can be used in both wet and dry stages of the concrete, allowing the masons to achieve the desired texture and finish. Screeds are employed during the initial stages of the pour to level and flatten the concrete. A screed is a long, straight board or bar that is dragged across the surface of the wet concrete. By pushing and pulling the screed along the guides or formwork, the masons distribute the concrete evenly, removing excess material and creating a uniform thickness. This process ensures that the concrete is level and ready for further finishing. Once the concrete has been poured and leveled, it undergoes a crucial process of hardening and curing. After approximately 4 hours, the concrete reaches a stage where it has hardened enough to support the weight of the workers. At this point, the cement masons employ concrete power trowels and hand trowels to further refine the surface and achieve the desired finish. Concrete power trowels are mechanical tools that consist of rotating blades attached to a motorized base. These machines are used to cover larger areas efficiently and produce a smooth and polished surface. The power trowel is guided by the workers, who control its movement and pressure to ensure an even and consistent finish. The blades of the power trowel rotate rapidly, effectively compacting the surface and removing any imperfections or air pockets in the concrete. By carefully maneuvering the power trowel across the concrete, the workers achieve a dense and durable surface with a uniform appearance. While power trowels are excellent for large-scale concrete pours, hand trowels play a crucial role in refining smaller or hard-to-reach areas. Hand trowels consist of a flat metal blade attached to a handle, allowing the workers to manually smooth and shape the concrete. With precise control and skill, the workers use hand trowels to fill in low spots, eliminate high spots, and create a level surface. Hand trowels are particularly useful in corners, edges, and areas that cannot be reached by power trowels. Gomaco equipment utilizes innovative concrete slipform paving technology to construct roads with precision and efficiency. The process begins with the preparation of the subgrade and the installation of guiding systems, including string lines or 3D machine control, to ensure accurate alignment and grade control. Once the setup is complete, Gomaco's equipment is brought into action. At the core of Gomaco's Slipform paving technology is the Slipform paver, a specialized machine designed to continuously extrude and shape concrete. The machine moves forward at a controlled pace, guided by the predetermined path. The Slipform paver is equipped with a mobile chassis and an adjustable paving mold. As the machine advances, 2 concrete mixer trucks pours the mixed concrete directly in front of the Slipform paver. The machine's mold receives the concrete and distributes it evenly across the width of the mold. Gomaco's Slipform paver incorporates various mechanisms to shape the concrete as it is extruded. Hydraulically adjustable side forms confine the concrete and define the desired shape of the road. Tamper bars and vibrating screeds work together to compact and finish the concrete surface, ensuring proper density and a smooth, level pavement. Augers are utilized to distribute any excess concrete evenly and provide lateral support to the machine. To maintain precision and accuracy, Gomaco's Slipform pavers are equipped with advanced control systems. These systems employ sensors and feedback mechanisms to monitor the machine's position, speed, and other critical parameters. Real-time data processing allows the machine to make necessary adjustments, ensuring the desired profile and surface finish are maintained throughout the paving process. Curb roller manufacturing is revolutionizing the construction industry with its innovative Hydra screed, a powerful and efficient tool that simplifies the process of screeding shed floors. The Hydra screed, powered by the Hydra Pack, offers an unparalleled level of control and precision, ensuring a perfectly flat and even surface every time. One of the standout features of the Hydra screed is its use of a rail system. This rail allows the screed to float effortlessly across the floor, eliminating the need for manual labor and reducing operator fatigue. The smooth movement of the screed, combined with the power of the Hydra Pack, guarantees a superior finish that is both visually appealing and structurally sound. With the Hydra screed, bull floating and finishing become a breeze. The powerful Hydra Pack provides consistent and reliable performance, allowing contractors to complete their projects efficiently and effectively. This advanced technology takes the guesswork out of the process, ensuring that even inexperienced operators can achieve professional-grade results. Not only does the Hydra screed deliver exceptional performance, but it also saves time and labor costs. By streamlining the screeding process, contractors can optimize their workflow and take on more projects, ultimately increasing their profitability. Curb Roller's Hydra screed is a game changer in the construction industry, offering an easy and efficient solution for achieving perfectly leveled shed floors. With its cutting-edge technology and superior performance, the Hydra screed sets a new standard for quality and productivity in the field of concrete finishing. When it comes to achieving success in concrete projects, custom drums play a pivotal role in shaping the outcome. Curb roller manufacturing understands the challenges that contractors face, particularly in unique projects like drainage ditches, where multiple pours are often required. However, with custom drums, these hurdles can be overcome, leading to enhanced efficiency and superior results. By utilizing custom drums from curb roller manufacturing, contractors can eliminate the need for multiple pours. This eliminates the constant weather checking and uncertainty regarding the placement of different sections. With custom drums, each pour is precisely tailored to meet the project's specifications, ensuring a uniform and consistent finish. There are no inconsistencies, low spots, or the need for redundant cross-forming. The advantages of custom drums go beyond achieving a uniform finish. With the assurance of a reliable shaping solution, contractors can confidently allocate their crew to other projects, maximizing productivity and profitability. Custom drums offer a tailored and efficient approach to concrete shaping, providing contractors with the tools they need to deliver exceptional results. Railroad demolition projects require specialized equipment and skilled operators to efficiently and safely dismantle existing tracks and infrastructure. One such project took place at Paradeplatz in Zurich, where the Eberhard Company undertook the challenging task of removing the railway tracks. This case study explores the equipment utilized and the methods employed during the demolition process. The Eberhard Company employed a range of heavy machinery, including the CAT 395F and CAT 352F excavators, along with the CAT 329E loader, to facilitate the Paradeplatz railroad demolition. Each machine was equipped with specialized attachments designed to perform specific tasks. The CAT 395F excavator, fitted with a specialized bucket attachment, was utilized to shovel the road and rails. This robust bucket attachment, tailored for railroad demolition, had reinforced edges and teeth to withstand the demanding conditions. It allowed operators to efficiently scoop up the road and rail materials, making the process more time-effective. To chisel down the road, the CAT 352F excavator was utilized, equipped with a specialized hammerhead attachment. This attachment, designed specifically for breaking down hard surfaces, enabled the operator to methodically chip away at the road material, facilitating its removal. The precise control offered by the CAT 352F and the hammerhead attachment ensured accurate and targeted demolition. In addition, the CAT 329E loader played a crucial role in the project. Its primary task was to shovel sand onto trucks for disposal or reuse. With its sturdy construction and high lifting capacity, the CAT 329E loader efficiently loaded sand into trucks, ensuring a streamlined process for material removal. The Paradeplatz Railroad demolition project followed a systematic approach. First, the CAT 395F excavator with the specialized bucket attachment was used to lift the road and rails, allowing for easier access to the underlying infrastructure. Simultaneously, the CAT 352F excavator, equipped with the hammerhead attachment, chiseled down the road, breaking it into manageable pieces. Once the road was sufficiently dismantled, the CAT 329E loader came into action, shoveling sand onto waiting trucks. This step ensured efficient disposal of the excavated material, clearing the way for further progress. The loaders were also responsible for transporting necessary supplies and equipment to the site, contributing to the overall project logistics. The construction of the Istanbul Airport project involves a significant volume of work and various components, each contributing to the overall functionality and success of the airport. The utility and infrastructure systems of the project entail the construction of extensive networks, including approximately 200 kilometers of water supply pipelines, 150 kilometers of sewerage systems, and 250 kilometers of electrical grids and telecommunications infrastructure. These systems are designed to efficiently supply water, manage waste, and provide reliable power and communication throughout the airport complex. The utility and infrastructure systems include water supply networks, sewerage systems, electrical grids, and telecommunications infrastructure. The construction of these systems ensures the efficient flow of essential resources throughout the airport complex, supporting the needs of passengers, airlines, and airport personnel. The installation of the baggage handling systems is a critical aspect, with the project incorporating state-of-the-art technology. It includes the installation of approximately 20 kilometers of conveyor belts, advanced sorting mechanisms, and security screening equipment. These systems are capable of handling a staggering volume of luggage, processing an average of 30,000 bags per hour. To accommodate the needs of passengers and airport users, the project involves the construction of expansive parking areas. This includes the development of multi-level parking structures capable of accommodating over 40,000 vehicles, as well as open-air parking lots with a capacity of more than 20,000 vehicles. Additionally, designated areas for short-term and long-term parking are being created, providing convenient options for travelers and airport staff. The construction of hangars and maintenance facilities is another crucial aspect of the project. It includes the construction of multiple hangars with a combined area of over 100,000 square meters, capable of accommodating a large number of aircraft simultaneously. These facilities are equipped with advanced maintenance equipment and technologies to ensure efficient servicing and repairs of the aircraft. The Istanbul Airport project also places a strong emphasis on landscaping and environmental considerations. It involves the creation of lush green spaces, gardens, and recreational areas spanning approximately 300,000 square meters. These areas not only enhance the aesthetic appeal of the airport, but also provide a pleasant environment for passengers and visitors. In terms of tunnel construction, the project includes the development of tunnels for transportation and maintenance purposes. These tunnels span a total length of approximately 10 kilometers and serve as vital passageways for vehicles, personnel, and utility systems within the airport complex. To ensure the efficient operation of the tunnels, the project incorporates the installation of comprehensive mechanical, electrical, and plumbing systems. This includes the implementation of advanced ventilation systems, over 100 kilometers of electrical wiring, and plumbing networks that span the entire tunnel network. These systems provide optimal lighting, air quality, and utility services to support smooth operations and maintenance activities. The construction of the fuel transfer system is a significant undertaking, involving the installation of underground pipelines with a total length of approximately 15 kilometers. These pipelines connect the fuel storage tanks, which have a collective capacity of over 5 million liters, ensuring a reliable and efficient fuel supply for aircraft operations. Additionally, a fuel station equipped with multiple fuel tanks is being constructed to meet the refueling needs of ground vehicles at the airport. As the demand for electric vehicles continues to grow, the Istanbul Airport project includes the installation of electric charging systems. This entails the deployment of over 200 electric charging stations strategically placed throughout the airport complex, enabling passengers and airport personnel to conveniently recharge their electric vehicles. The communication and network systems of the project encompass a comprehensive infrastructure. This includes the installation of over 1,000 kilometers of fiber optic cables, wireless connectivity across the entire airport area, and the implementation of advanced voice communication systems. These systems facilitate efficient and reliable communication between airport staff, airlines, and passengers, ensuring seamless operations and information flow. The construction of an operation control center is a pivotal aspect of the project, serving as the central hub for monitoring and managing airport operations. Equipped with cutting-edge technology, surveillance systems, and communication networks, the control center provides real-time monitoring, decision-making, and coordination. It encompasses an area of approximately 5,000 square meters and houses a dedicated team responsible for ensuring the smooth functioning of the airport. The Istanbul Airport project is one of the largest and most ambitious infrastructure developments in recent history. The first phase alone was completed in a record-breaking timeframe of just 42 months, showcasing the sheer scale and efficiency of the project. With an estimated cost of around 10 billion euros, the Istanbul Airport project has attracted attention from around the world. It has been hailed as an architectural and engineering masterpiece, showcasing Turkey's commitment to developing world-class infrastructure. Upon completion, the Istanbul Airport is expected to have a total annual passenger capacity of around 200 million, making it one of the largest airports in the world. Discusses the engineering, project planning, manufacturing, and construction of the Sims U.S. cement plant in St. Genevieve, Missouri. It highlights the use of advanced technology and equipment, teamwork between Florida Schmidt and Holcim, exceptional logistics and timing, and the challenges faced in designing a plant next to an unpredictable river and within the constraints of a nature reserve. The Holcim cement plant in St. Genevieve, Missouri, is a state-of-the-art facility that plays a significant role in the cement industry. It is one of the largest cement plants in the United States. Located on the Mississippi River, the St. Genevieve plant benefits from its strategic location, allowing for efficient transportation of raw materials and finished products. With its modern equipment and environmentally friendly design, the plant adheres to strict emission standards, ensuring minimal impact on the surrounding environment. With the key role in planning, design, construction, and startup, Florida Schmidt made significant contributions to the success of the Holcim cement plant project in St. Genevieve. Site mobilization and civil work, including the preparation of roads, utilities, and the plant site, were meticulously carried out. Roads were prepared, ensuring efficient access to the site for transportation of equipment and materials. Utilities, including water supply, power distribution, and waste management systems, were meticulously installed to support the plant's operations. Components such as silos were assembled, providing storage for raw materials. Furthermore, strong foundations were laid to support the main plant structures, ensuring their stability and longevity. These crucial activities set the stage for subsequent construction phases and were carried out with meticulous attention to detail to create a solid infrastructure for the successful completion of the plant. Over 50 cranes are deployed during peak operation to lift and assemble the tower's large pre-assembled components. Each crane and the overall preheater assembly must be executed with utmost precision to ensure structural integrity and seamless integration with the rest of the plant. Standing at an impressive height of 120 meters, the preheater tower is constructed using steel and consists of multiple stages or cyclones. Its purpose is to preheat and partially calcine the raw materials before they enter the kiln for further processing. By utilizing a counter-current flow, the preheater tower allows hot gases from the kiln to pass through the descending raw materials, facilitating efficient heat transfer. This design maximizes the preheating process's effectiveness while reducing energy consumption. The kiln live rings, weighing approximately 220 tons each, are a critical part of the kiln assembly. These rings are responsible for providing structural support and stability to the kiln, ensuring its reliable operation during the cement production process. Due to their immense size and weight, the casting process requires advanced engineering techniques and specialized facilities. Manufacturers in Korea, known for their expertise in large-scale casting and engineering, take up the challenge of producing these kiln live rings. Once cast, the live rings undergo a series of stringent quality control measures, including tempering and machining processes, to ensure their integrity and compliance with the project specifications. After completion, the kiln live rings are then shipped from Korea to the St. Genevieve plant, completing a remarkable journey across continents. The kiln is responsible for the final stage of the cement production process, clinker production. It is a large cylindrical structure where raw materials are heated at high temperatures to transform them into clinker. The St. Genevieve plant has the world's largest single kiln clinker production line. With a diameter of 6.6 meters and a length of 98 meters, the kiln has a staggering capacity to produce 12,000 tons of clinker per day. The kiln is a highly precise and critical piece of equipment, requiring meticulous installation and assembly to meet the stringent tolerances necessary for efficient and reliable operation. Once the plant is fully built, it is time to proceed with the crucial step of conducting test runs to ensure its functionality and efficiency. The test run phase involves a series of comprehensive checks and trials to validate the plant's equipment, systems, and processes. This stage is essential to identify any potential issues, fine-tune operations, and make necessary adjustments before commencing full-scale production. During test runs, each component of the plant is meticulously evaluated. The electrical systems are examined for proper functioning, ensuring that all controls and automation are operational. The mills, coolers, and separators are put through their paces to verify their performance and efficiency. Additionally, the kiln, the heart of the cement production process, undergoes trial runs to assess its capacity and heat distribution. Throughout the test run phase, data is collected and analyzed to optimize performance and fine-tune operational parameters. This includes monitoring temperature, pressure, energy consumption, and product quality. Any deviations or anomalies are promptly addressed to achieve the desired results. The test run phase is also an opportunity to train the plant's operating personnel. They familiarize themselves with the equipment, processes, and safety protocols, ensuring they are prepared for the upcoming production phase. Commissioning is a crucial phase in the construction of a cement plant, marking the transition from testing and trial runs to full-scale production. It involves the systematic process of verifying and fine-tuning all plant systems, equipment, and processes to ensure optimal performance and operational readiness. During commissioning, the plant's functionality is thoroughly assessed and validated. This includes checking the proper functioning of electrical systems, control panels, instrumentation, and automation. The performance of key components such as mills, kilns, coolers, and separators is evaluated to ensure they meet design specifications and operational requirements. Commissioning also involves conducting performance tests, analyzing data, and making adjustments to optimize productivity, energy efficiency, and product quality. The plant's safety protocols, emergency systems, and environmental controls are reviewed and tested to ensure compliance with regulatory standards. Chemrock cut and break technology is a groundbreaking method that has proven to be highly effective in quarrying and demolition projects where traditional drilling and blasting techniques are not feasible or suitable due to various reasons, such as vibration sensitivity in the surrounding areas. The cut and break method involves a series of precise steps to safely and efficiently extract or demolish materials. The process begins by using a specialized DMW cutter wheel to cut multiple slots into the material. The DMW cutter wheel is designed to perform precise and controlled cuts, ensuring the integrity of the surrounding structures and minimizing any potential risks. The cutting process serves to distress the material, creating a weakened zone along the desired break line. This allows for controlled fragmentation and subsequent removal or demolition of the material. The DMW cutter wheel is highly efficient in cutting through various types of materials, including concrete, rock, and even reinforced concrete. Once the slots have been cut, the next step involves breaking the material along the weakened lines. ChemRock provides a range of tools for this purpose, including the cut and break tool, which is specifically designed for the cut and break method. The cut and break tool works in conjunction with excavators or other heavy machinery to apply controlled force and break the material into manageable pieces. In addition to the cut and break tool, alternative options such as buckets or ripping teeth can also be employed to further facilitate the breaking process. The choice of tool depends on the specific requirements of the project and the nature of the material being dealt with. The ChemRock cut and break technology offers several advantages over traditional drilling and blasting methods. Firstly, it eliminates the need for explosives, making it a safer and more environmentally friendly option. It also significantly reduces vibration and noise levels, making it ideal for projects in sensitive areas, such as urban environments or near existing structures. Furthermore, the precise cutting and controlled breaking offered by ChemRock's technology allow for greater accuracy and efficiency in material extraction or demolition. This leads to reduced downtime and increased productivity on the job site. The Metso Locotrack LT220D is a mobile crushing and screening plant that revolutionizes the way crushing and screening operations are conducted. This innovative solution combines a crusher and a screen into a single unit, providing enhanced efficiency, flexibility, and ease of transportation. At the core of the LT220D plant is the Nordberg GP220 trademark cone crusher and the dual-slope high-efficiency screen. The GP220 trademark cone crusher ensures high-quality end products and efficient crushing performance. It is designed to crush various types of materials, including hard and abrasive rocks, making it suitable for a wide range of applications. The dual-slope screen of the plant offers excellent screening accuracy and efficiency. It has a large screening area and adjustable inclination, allowing precise separation of different-sized materials. The screen is capable of producing up to 4 different fractions simultaneously, making it highly versatile. The mobile design of the Locotrack plant enables easy transportation between job sites. It can be transported as a single unit on a trailer, minimizing the need for disassembly and reassembly. This mobility enhances productivity by reducing downtime and enabling quick setup at different locations. The LT220D is equipped with advanced features to optimize performance and user experience. It has a user-friendly control system that provides real-time data and monitoring of key parameters, ensuring efficient operation and maximizing uptime. Additionally, it can be operated remotely, further enhancing safety and convenience. The Metso plant offers numerous benefits to crushing and screening operations. Its integrated design saves space, reduces investment costs, and simplifies logistics. The ability to produce multiple fractions simultaneously increases operational efficiency, while the high-quality end products meet the strictest specifications. The production of cement at the Ohorongo cement factory in Namibia involves several steps, starting from the initial blasting and quarrying of raw materials. Let's delve into each step in more detail. Blasting and quarrying. The process of cement production begins with blasting, where holes are drilled to a certain depth in the quarry. Sausage-shaped cartridges are then lowered into the holes with detonating cords. Highly trained staff handle this task with utmost care and precision. The cartridges are filled with free-flowing ammonium nitrate, commonly known as ANFO, to a depth of approximately 1.5 meters. A detonator is added, and the hole is filled with gravel. Once all the necessary safety precautions are in place, the blast is set off using a fuse with a 4-minute delay. Raw material collection and crushing. Following the blasting, the rubble consisting of limestone, shale, and marl is loaded onto large trucks with a capacity of 60 tons each. These raw materials are transported to the crusher, where they are crushed into a rough gravel-like consistency. The crusher at Ohorongo Cement Factory can handle an impressive 600 tons of raw materials per hour, ensuring a steady supply for the production process. Mixing and homogenizing. The crushed limestone, shale, and marl are conveyed to the mixing bed, where they are blended to create a homogeneous mixture. The mixing bed has a radius of 81 meters and a height of 28 meters, capable of accommodating up to 25,000 tons of mixed materials. The quality department closely monitors the chemical composition of the material to ensure the correct proportions of limestone, shale, and marl. If necessary, essential additives such as quartz sand and iron ore are added to the mixture to achieve the desired composition. Grinding and drying. The homogenized mixture is then conveyed to the raw mill, where it undergoes grinding and drying processes. Roller mills, which are more energy efficient compared to traditional ball mills, are utilized at Ohorongo Cement Factory. These roller mills reduce the total electrical power consumption by about 30% in comparison. The mixture is ground to a fine powder with the consistency of fine flour, while simultaneously being dried using the redundant heat generated from the firing process. Preheating and burning. Once the mixture has been ground and dried, it enters the preheater, a towering structure standing at 109 meters, making it one of the tallest structures in Namibia. In the preheater, the raw meal is preheated by utilizing the excess heat from the rotary kiln, significantly reducing the time and energy required for the subsequent burning process. Rotary kiln and clinker formation. After the preheating stage, the processed material enters the 54-meter-long rotary kiln, where it undergoes the burning process to transform the raw meal into clinker. The intense heat in the rotary kiln, with temperatures reaching 1,450 degrees Celsius, ensures the chemical transformation of the raw meal into clinker, which consists of fused clumps of nodules. Clinker cooling and storage. Once the clinker is formed in the rotary kiln, it is cooled down using a method called air quenching instead of traditional water conditioning. Cement milling and packaging. To produce cement, the cooled clinker is mixed with gypsum and other additives, such as high-grade limestone if required. The mixture is then finely ground in cement mills to achieve the desired particle size. Ohorongo Cement Factory utilizes 2 cement mills, each capable of handling 65 tons of cement per hour. The finely ground cement is stored in separate cement silos with a capacity of 7,500 tons each. The final step in the production process is the packaging of the cement. The cement produced at Ohorongo is packaged in 50-kilogram bags, bulk bags, or cement tankers, depending on customer requirements. Robotic machines are employed to count and stack the bags on pallets, which are then shrink-wrapped for additional handling and protection. The packaging plant has a capacity to handle 4,400 bags per hour, ensuring efficient packaging and distribution of the cement. Throughout the entire cement production process, highly qualified personnel continuously monitor and control each step to ensure the highest quality standards. Advanced filtering systems are in place to minimize air pollution and adhere to environmental regulations. The Route 58 rehabilitation project in Southampton County, Virginia, is implementing a new approach to road construction by utilizing hydraulic cement concrete paving instead of traditional asphalt overlay. This alternative method aims to reduce reliance on oil and its fluctuating prices. The use of hydraulic cement concrete offers several advantages, including continuous reinforcement with steel throughout the pavement, eliminating the need for joints and providing a smoother ride. The process begins by shot blasting the existing concrete pavement to remove oil and debris, preparing it for the overlay. The concrete is then transported from the plant and spread across the road using a spreader, ensuring adequate coverage. The next piece of equipment consolidates the concrete, ensuring the desired thickness and cross-section. Finally, a curing compound is applied, and small grooves are raked into the pavement. These grooves enhance traction and channel water away from the travel lanes, improving safety. The paving process is guided by sophisticated machinery equipped with a global positioning system, GPS. This ensures precise alignment and thickness, resulting in a high-quality road surface. The Virginia Department of Transportation's research arm, the Virginia Center for Transportation Innovation and Research, will closely monitor the performance of the new concrete pavement over the years to assess its long-term durability. The expected lifespan of the pavement is estimated to be around 30 years. For the ditch liner project, Curb Roller Manufacturing designed and created an oversized custom drum, measuring 24 feet wide, 1,000 pounds in weight, and 52 inches in diameter. The drum consisted of two 8-foot wide wing sections and an 8-foot wide flat pan section in the middle. It was specifically built to streamline the concrete pouring process and enhance efficiency. The drum was attached to a cable trolley system on both sides and powered by the Hydra screed, allowing it to be pulled along the ditch. The spinning action of the drum served multiple purposes. Firstly, it brought the cream and fat of the concrete mixture to the surface, ensuring a smooth finish. Secondly, it pushed the aggregate down, preventing it from settling on the sides and creating inconsistencies or low spots. By utilizing this oversized custom drum, several benefits were achieved. Construction joints on both sides of the flume bottom, doweling, and redundant cross-forming were eliminated. The continuous pour technique made it unnecessary to stop and muck out the wings and pan after rain, reducing downtime. Additionally, a minimum of 600+ man-hours were saved, and the overall quality of the project was improved. The Gomaco GT3600 concrete curb and gutter slipform machine is a specialized piece of equipment designed for precise and efficient concrete paving, particularly in tight, radii island applications. As the machine starts operating, it receives data from the 3D guidance system, which allows it to accurately follow the predetermined path. The slipform process begins by dispensing concrete into the hopper, which then flows into an auger conveyor. The auger evenly spreads the concrete and eliminates any excess material. Simultaneously, the machine's molds shape the concrete into the desired curb and gutter profile. The molds are adjustable, allowing for customization based on project requirements. Vibrators are incorporated to ensure proper compaction and to achieve a smooth and durable finish. Throughout the process, the 3D guidance system continually provides feedback to the machine, ensuring that it maintains the correct elevation, alignment, and curvature. This integration of technology significantly reduces the need for physical string lines or manual adjustments, resulting in increased efficiency and precision. In tight, radii island paving, where complex curves and tight turns are involved, the Gomaco GT3600 with 3D guidance excels in maintaining accuracy and maneuverability. Its ability to precisely navigate these challenging areas allows for the creation of smooth, seamless, and aesthetically pleasing concrete islands. Concrete tetrapod breakwaters play a crucial role in coastal protection and the stabilization of shorelines against erosion caused by waves and currents. These structures are designed to withstand the relentless forces of the ocean and provide a durable defense system for coastal areas. Their importance cannot be overstated, as they help safeguard human settlements, infrastructure, and valuable ecosystems along the coast. One of the key advantages of concrete tetrapod breakwaters is their ability to dissipate wave energy. The unique shape of tetrapods, with 4 legs and a wide top, helps to scatter and break the incoming waves, reducing their power before they reach the shoreline. This dissipation minimizes the erosive impact on the coast, preventing land loss and maintaining the stability of beaches. Concrete tetrapods are specifically designed to withstand the harsh marine environment. Their construction involves using high-strength reinforced concrete, ensuring the structures can withstand extreme wave loads, abrasion, and corrosion. The weight of each tetrapod contributes to its stability, anchoring it firmly in place and preventing displacement during storm events. The effectiveness of concrete tetrapod breakwaters can be seen in various real-world examples. For instance, the tetrapod breakwater in Wismar, Germany, constructed in the Baltic Sea, has provided reliable coastal protection for decades. Similarly, the tetrapod breakwater in Osaka Bay, Japan, has successfully defended the coastline against typhoon-induced waves, preserving the shoreline and adjacent areas. Moreover, the economic benefits of concrete tetrapod breakwaters are noteworthy. By safeguarding coastal infrastructure and properties, these structures save millions of dollars in potential damages caused by erosion and storm events. They also contribute to the preservation of valuable ecosystems, such as coastal wetlands and habitats for marine organisms, which are crucial for 952E excavator, a heavyweight in the construction industry, has raised the bar with its latest configuration featuring a remarkable 24 meters super long boom. Designed to excel in projects such as river dredging, water conservancy, and more, this powerhouse machine combines robust performance, stability, and extended reach. Equipped with a high-performance diesel engine, the Lugan 952E delivers exceptional power and fuel efficiency, ensuring optimal performance in the most demanding environments. With an operating weight of 50 metric tons, this excavator offers the necessary stability to tackle challenging tasks, guaranteeing smooth operations and enhanced safety. The 24 meters super long boom on the Lugan 952E excavator is a game changer, enabling operators to reach greater distances and depths with ease. This extended reach allows for efficient excavation and dredging in large-scale projects, providing a significant advantage in applications that demand precision and flexibility. With a digging depth of 7.6 to 8.5 meters, the Lugan 952E excavator is capable of performing deep excavations efficiently. Whether it's digging foundations or working on water infrastructure projects, the machine delivers exceptional digging performance, ensuring projects progress swiftly and accurately. This is a 270-ton long-reach excavator, a powerful and specialized piece of heavy equipment designed for specific construction and maintenance tasks. With its impressive weight of 270 tons, this excavator is capable of handling large-scale projects with ease. One of the standout features of this excavator is its 3-part excavator boom, which spans an impressive length of 42 meters. The boom is responsible for extending the reach of the excavator, allowing it to access areas that are typically difficult to reach. This feature makes it ideal for tasks such as trimming batter slopes and placing armor rock on reclamations and seawalls. The steel components for the boom were manufactured by Real Steel, a reputable company known for producing high-quality construction materials. Heron Construction, a New Zealand-based company, then fabricated the boom using these components, ensuring the final product meets the highest standards of durability and performance. The long-reach excavator works by utilizing hydraulic power to control its movements. The operator sits in a cabin situated on the main body of the excavator and operates the controls to manipulate the boom, bucket, and other attachments. The hydraulic system enables precise and efficient movements, allowing the excavator to handle various tasks with accuracy. This is a river dredging project of River Machinery in Wuhan, China. This video records the whole process of the construction program. The Amphibious excavator, equipped with a cutter suction pump, is a powerful tool used for river dredging. This innovative combination of equipment brings efficiency and cost effectiveness to dredging projects, surpassing traditional excavators in performance. Let us delve into the details and witness the excellent dredging efficiency of this swamp buggy. At the heart of this powerful tool is the XE200DA Amphibious excavator, designed and manufactured by River Machinery. With an operating weight of 21,200 kilograms, this excavator provides the necessary stability to work in challenging environments. It boasts an impressive bucket capacity ranging from 0.93 to 1.1 cubic meters, enabling it to handle significant volumes of dredged material efficiently. The XE200DA excavator's remarkable digging force further enhances its capabilities. With a bucket digging force of 149 kilonewtons and an arm digging force of 121 kilonewtons, it can tackle various types of soil and sediment with ease. This immense power enables the excavator to extract material effectively, streamlining the dredging process. This amphibious excavator carries cutter suction pump, is easy to transport and install. It only takes 1 hour to disassemble or install. In terms of dimensions, the XE200DA is designed to maneuver through water and challenging terrains. It has an overall length of 9,625 millimeters, an overall width of 2,910 millimeters, and an overall height of 3,100 millimeters. These dimensions provide the excavator with excellent stability while operating in wetlands, swamps, and rivers. One of the key factors in river dredging is the ability to reach deep into the riverbed. The XE200DA excavator excels in this regard, with a maximum digging depth of 6,460 millimeters. This depth allows it to efficiently extract material from the river floor, ensuring optimal dredging results. Additionally, its impressive maximum digging radius of 9,790 millimeters and a minimum swing radius of 3,530 millimeters provide excellent reach and maneuverability during the dredging process. To further enhance its capabilities, the XE200DA Amphibious excavator is equipped with a cutter suction pump. This accessory is specifically designed to remove sediment and debris from the riverbed effectively. The cutter suction pump employs a rotating cutter head to break up compacted materials, while the suction system removes the loosened sediment and transports it away. This combination of the excavator and the cutter suction pump allows for efficient and precise dredging, resulting in a cleaner and more navigable river. The advantage of the amphibious excavator with a cutter suction pump lies in its versatility and mobility. Traditional dredging equipment often faces limitations in reaching inaccessible areas. However, the amphibious excavator, with its ability to traverse both land and water, can access remote locations with ease. This versatility enables the efficient dredging of rivers, lakes, and other bodies of water, ensuring the proper maintenance of waterways and supporting various industries such as construction, mining, and infrastructure development. These amphibious excavators excel in river dredging, lake development, wetland park construction, coastal beach development, salt lake development, tailings control, and more. One of their standout features is the amphibious lightweight design. The pontoon buoyancy is carefully calculated to be less than the total machine weight, including the upper structure and undercarriage. This allows the excavator to operate in shallow water with exceptional flexibility, typically up to 1.8 meters depending on the model. The lightweight design also ensures stability and safety during operations. The excavator can land and maneuver steadily in shallow water, akin to land crawlers working on solid ground without the risk of rolling over. This feature enables the machine to perform digging tasks in various directions while prioritizing safety. Moreover, the compact and lightweight pontoon design offers additional benefits. It enhances marsh travel, making it easier to navigate through challenging terrains. Additionally, it provides a more flexible operation while delivering cost savings for customers. To expand the excavator's capabilities, a series of side pontoons and spuds can be paired with different undercarriage models. This allows the amphibious excavator to float in deeper water, ranging from 1.6 meters to a maximum of 5 meters. Such versatility enables the machine to effectively tackle a diverse range of work scenarios. The Watermaster Amphibious Multi-Purpose Dredger is a highly versatile and efficient machine designed for shallow water work up to a depth of 6 meters. It is transported as a complete unit, ready to start working without any setup times or additional assembly required. One of the standout features of the Watermaster Dredger is its self-launching capability, eliminating the need for crane assistance. The machine is self-propelled and can easily enter the water independently, making it a highly mobile and convenient option for various waterway projects. The Watermaster Dredger operates smartly and independently, without the need for wire, cables, or assisting vessels. It is equipped with its own propulsion system, allowing it to navigate and maneuver efficiently in the water. This eliminates the dependence on external resources and enhances the overall productivity of the machine. One notable aspect of the Watermaster Dredger is its multi-purpose capabilities. It can perform dredging, raking, piling, and other tasks, eliminating the need for multiple specialized machines. This versatility makes it a cost-effective solution for a wide range of projects. The machine also boasts a large work area, allowing for increased production with less repositioning. Its 180-degree working radius and over 110 square meters of workspace enable efficient and effective operations. This means that more work can be completed without the need for frequent repositioning, saving time and increasing productivity. Equipped with a submersible Watermaster cutter pump, the dredger offers impressive dredging capacity ranging from 500 to 900 cubic meters per hour. This powerful pump ensures efficient removal of sediment, silt, and other materials from shallow waterways. The Watermaster Dredger is particularly well suited for applications such as the maintenance and deepening of shallow waterways. It can effectively remove sediment, improving water flow and navigation. Additionally, the machine is capable of discharging dredged materials up to 1.5 kilometers away, providing flexibility in disposal options. The environmental applications of the Watermaster Dredger are noteworthy. It can contribute to flood prevention by removing excess sediment and debris that may obstruct water flow. Additionally, the machine is highly effective in the removal of trash and invasive vegetation, restoring and maintaining the natural balance of aquatic ecosystems. In construction applications, the WaterMaster dredger proves its value in water-based infrastructure projects. It can assist in the construction and maintenance of marinas, piers, floodwalls, and other water-related structures, ensuring their functionality and safety. Industrial applications of the WaterMaster dredger include pond maintenance and the recovery of valuable materials. It can efficiently remove sediment and contaminants from industrial ponds, improving water quality. Moreover, it can recover valuable materials, such as sand or gravel, from underwater deposits. The WaterMaster dredger's ease of movement between work sites is a significant advantage. It can be transported as a complete unit and does not require a crane for launching or setup. This mobility allows for quick and efficient relocation between different project locations, saving time and resources. This is a Hitachi X8000 excavator at Mount Keith Nickel Mine in Western Australia. It was one of the first Hitachi X8000 mining excavators in Australia. The Hitachi X8000 excavator is an engineering marvel, particularly when considering its weight alone. Weighing a staggering 825 tons, it is equivalent to twice the weight of a fully loaded Boeing 747 aircraft, approximately 400 tons. Its sheer size and impressive capabilities have revolutionized the way mining operations are conducted in Australia. Equipped with advanced technology and engineering, this excavator is designed to handle the most challenging tasks in the mining industry. In terms of appearance, the X8000 stands tall at 10 meters and spans 8 meters in width. With a ground clearance of 1.2 meters, it resembles a 3-story mobile building from a distance. The world's largest excavator, the Hitachi X8000, requires an immensely powerful heart to start and operate smoothly. In this case, it relies on two Cummins QSKT60C engines, each with a power output of 1,450 kilowatts, equivalent to 1,940 horsepower. Additionally, it features 16 cylinders and a turbocharging system, enabling the machine to operate with strength and agility despite its massive size. After considering the importance of a robust heart, we turn our attention to the gigantic weapon of this excavator. If the X8000 were a heavily armored warrior, its sword would be the largest bucket in the world. The X8000 is equipped with a colossal bucket with a capacity of 38 to 43 cubic meters, depending on whether it is a forward or reverse bucket. This means that a single scoop of the X8000's bucket is equivalent to the load of 6 11-ton trucks. In the Carrara quarry, Italy, where the extraction of magnificent marble blocks takes place, the collaboration between two formidable excavators, the Liebherr 974 and the Liebherr R 984, becomes a spectacle of engineering prowess. Their combined efforts are dedicated to the crucial task of separating and dumping these colossal rocks after they have been cut from the quarry walls. The Liebherr 974, with a weight of 85.2 tons, stands tall and sturdy, ready to tackle the demanding quarry environment. Powered by an impressive 400 kilowatts engine, it possesses the strength and agility required for efficient and precise operations. With a maximum horizontal reach of 12.2 meters and a tear-out force of 358 kilonewtons, this excavator is well equipped to handle the substantial task at hand. Joining forces with the Liebherr 974 is the mighty Liebherr R 984C excavator, boasting a weight of 120.1 tons. This behemoth of a machine, powered by a Cummins engine with a robust 523 kilowatts, further amplifies the excavation capabilities. With a maximum horizontal reach of 13.7 meters and a tear-out force of 416 kilonewtons, it complements the Liebherr 974 perfectly, enhancing their collective ability to manipulate and handle the massive marble blocks. Once the marble blocks are cut from the quarry, the synchronized efforts of these two excavators come into play. Their skilled operators maneuver the machines around the rocks with utmost precision and care. Using the hydraulic arms of the excavators, they delicately pry apart the sections, taking advantage of fissures within the rock. This process minimizes the risk of damage to the marble and ensures the separation is executed flawlessly. With the blocks successfully separated, the excavators proceed to the next stage, dumping. The immense buckets of the Liebherr 974 and the Liebherr R984C effortlessly lift and carry the sections, positioning them precisely in the designated dumping areas. Their synchronized movements and synchronized efforts guarantee a seamless workflow, enabling swift and efficient loading onto waiting trucks. Steel wrist SQ fully automatic quick couplers for excavators revolutionize the process of changing hydraulic attachments. With this advanced system, machine operators can safely switch between a wide range of attachments within seconds, all without having to leave the comfort and safety of the excavator cab. The steel wrist SQ quick coupler is equipped with the innovative front pin lock technology, which sets it apart as the most advanced hydraulic quick coupler available for excavators. This technology incorporates two key features that significantly enhance safety during attachment changes. The first feature of the steel wrist SQ is the snap-locked front shaft, which ensures that the front shaft of the attachments is securely locked as soon as it enters the front jaw of the coupler. This mechanism provides a strong and reliable connection, preventing any accidental detachment during operation. The second feature is the positive lock indication system. It offers an intuitive indication with a red indicator when the bracket is open and a green indicator when the attachment is safely positioned and locked in place. This visual feedback allows operators to quickly and easily verify the status of the attachment, enhancing safety and peace of mind. The demolition of a building using an excavator equipped with grapples is a highly effective method that offers numerous advantages in terms of efficiency, safety, and cost effectiveness. This technique involves the use of a mechanical shovel, typically weighing around 40 tons, equipped with grapple attachments designed specifically for demolition purposes. A recent example of such a project took place in Gaby-Willer, where Ferrari Demolition, a subsidiary of Cola's IDFN, successfully executed a building demolition on a construction site. One of the key benefits of using an excavator with grapples for demolition is its exceptional power and versatility. The sheer size and weight of the machine allow it to handle heavy-duty tasks efficiently. The grapple attachments, with their robust jaws and powerful hydraulic systems, enable the excavator to firmly grip and manipulate various materials, such as concrete, steel, and debris, with ease. This ensures that the demolition process is carried out swiftly and effectively, minimizing delays and maximizing productivity. Moreover, the precision and control offered by the grapples make it possible to selectively dismantle specific sections of the building, enabling the removal of hazardous or salvageable materials while minimizing collateral damage. This level of precision is crucial when demolishing structures in urban areas where neighboring buildings, infrastructure, or sensitive surroundings need to be protected. In terms of safety, using an excavator with grapples significantly reduces the risks associated with manual labor and traditional demolition methods. The operators can maintain a safe distance from the hazardous areas, operating the excavator from a protected cabin. The grapple attachments provide a secure grip on the materials, reducing the chances of accidents and ensuring that the debris is contained within the machine's reach. This enhances overall site safety and reduces the potential for injuries or damage to nearby structures. From a cost-effectiveness standpoint, the efficiency and speed of the demolition process using an excavator equipped with grapples translate into reduced labor requirements and project timelines. By minimizing manual labor and streamlining the process, companies can achieve significant cost savings. Additionally, the ability to salvage and recycle materials during the demolition process can contribute to cost reduction and environmental sustainability. The GET Amphibious Excavator GET 210 Pontoon with Hitachi ZX200 is a robust and versatile machine designed for excavation tasks in challenging amphibious environments. It combines the power and efficiency of the Hitachi ZX200 excavator with a specialized pontoon undercarriage, allowing it to operate in wetlands, swamps, and other water-rich terrains with ease. The Hitachi ZX200 excavator is known for its durability and performance. With an overall width of 2,860 millimeters, it provides stability and maneuverability in various working conditions. The overall length with a 2.91 meters arm is 9,660 millimeters, enabling the excavator to reach deep into excavation sites. The distance between tumblers is 3,370 millimeters, which ensures stability and balanced weight distribution during operation. The track shoe width is G600 millimeters, providing excellent traction and minimizing ground disturbance. The excavator's overall height of the cab is 2,950 millimeters, offering a comfortable and spacious working environment for the operator. The cab is equipped with advanced features and ergonomic controls, ensuring optimal visibility, ease of operation, and operator comfort. The GET 210 pontoon undercarriage is specifically designed to enhance the excavator's mobility in water-rich and challenging terrains. The pontoons are made of steel and provide excellent flotation and stability. With the pontoon undercarriage, the GET 210 can navigate through shallow water, muddy surfaces, and uneven terrains without sinking or getting stuck. This unique feature allows the machine to access remote or difficult-to-reach areas, which would otherwise be inaccessible for conventional excavators. The combination of the pontoon undercarriage and Hitachi ZX200 upper structure provides numerous advantages. It enables the GETM Amphibious Excavator GET 210 to perform a wide range of applications, including dredging, wetland restoration, shoreline maintenance, environmental remediation, and construction projects in water-rich areas. The excavator can effectively remove sediment, debris, and vegetation from water bodies, create and maintain water channels, construct foundations in wet soils, and perform other excavation tasks required in amphibious environments. The steel wrist SQ fully automatic quick coupler system has gained immense popularity among excavator operators in the UK in recent years. These couplers enable operators to swiftly change attachments, whether it's transitioning from a Furukawa breaker to a bucket or any other combination of hydraulic tools. By streamlining the attachment change process and eliminating the need for manual labor outside the cab, steel-wrist SQ quick couplers optimize efficiency, minimize downtime, and enhance overall productivity on the job site. They provide a safe and reliable solution for excavator operators, allowing them to focus on their tasks without unnecessary interruptions or risks. The NKR Demolition Group takes on an ambitious project involving the demolition of a 53-meter-high chimney using hydraulic crawler excavators equipped with a 50-meter long range and powerful demolition hammers. To begin the project, the team meticulously plans the demolition process, taking into account various factors such as structural integrity, safety precautions, and environmental considerations. With the plan in place, the hydraulic crawler excavators are deployed to the site, ready to showcase their capabilities. The excavators, specifically designed for heavy-duty demolition work, are equipped with demolition hammers as attachments. These powerful tools are crucial in breaking apart the solid materials comprising the chimney. The demolition hammer's chisel, like tips, deliver precise, high-impact forces that effectively dismantle the structure from top to bottom. With the 50-meter-long range of the excavators, they can reach great heights and access the upper sections of the chimney with ease. This extended reach ensures that no part of the structure is left untouched, allowing for a thorough and efficient demolition process. The operators skillfully maneuver the hydraulic crawler excavators, carefully controlling the demolition hammers to ensure the chimney's controlled collapse. The G-Trex Amphibious excavator is a versatile and powerful construction machine designed to operate in both land and water environments. It combines an excavator of various sizes, including 8 tons, 14 tons, and 20 tons, with a specialized amphibious undercarriage system. The G-Trex Amphibious undercarriage and long arm can be assembled with excavators from different brands, offering flexibility and compatibility. The main feature of the G-Trex Amphibious excavator is its ability to perform operations in challenging terrains such as marshes, swamps, ponds, and shallow water bodies. The unique undercarriage system consists of pontoon-like structures and tracks or wheels, enabling the machine to float and maneuver in water while providing stability and traction on land. To enhance its floating capacity, the G-Trex Amphibious excavator is equipped with additional components such as spud piles and side pontoons. Spud piles are vertical steel or concrete piles that can be raised and lowered using hydraulic cylinders or winches. They provide additional support and stability to the machine during water operations, minimizing excessive movement. Side pontoons are attached to the sides of the undercarriage, increasing the buoyancy and flotation capabilities of the excavator. The G-Trex Amphibious excavator is compatible with excavator models from various brands, allowing customers to choose the best fit for their specific requirements. It can be combined with excavators between the G-Trex Texas 140-2 or G-Trex TX 200-6 and the Komatsu PC 200-8. The Komatsu PC 200-8 is a renowned excavator model manufactured by Komatsu Limited, known for its reliability and performance in construction applications. The Komatsu PC 200-8 is equipped with a powerful Komatsu D107E engine, providing 173 HP, 129 kilowatts of power. It has an operational weight of 23,200 kilograms and a bucket capacity of 1.2 meters 3 for rock excavation. The main arm of the excavator measures 5,850 millimeters in length, while the boom arm is 3,000 millimeters long. The maximum digging height reaches 10,000 millimeters, and the maximum digging depth is 7,035 millimeters. The bucket digging force, according to SAE standards, is 152 kilonewtons, while the arm curling force is 119 kilonewtons. The excavator's maximum reach is 10,180 millimeters, providing a wide operational range. By combining the G-Trex Amphibious excavator with different excavator models and incorporating features like spud piles and side pontoons, the machine offers enhanced versatility and efficiency for a wide range of construction and dredging applications. It enables operators to tackle challenging environments, expand their operational capabilities, and complete projects more effectively. Whether it's dredging water bodies, constructing foundations in wetlands, or performing maintenance in marshy areas, the G-Trex Amphibious excavator provides a reliable solution for amphibious construction needs. The multi-purpose amphibian dredger Senwitech Dredge King is a versatile and efficient dredging machine designed to tackle various water-based projects. This remarkable dredger is capable of moving into the water autonomously, making it highly flexible and adaptable to different environments. Whether it's a shallow lake, river, or coastal area, the Dredge King is equipped to handle the task at hand. At the heart of the Dredge King is a high-performance sludge pump that ensures efficient dredging operations. The powerful protected double auger screw is specifically designed for operations in shallow water, allowing the dredger to effectively remove sediments and debris from the bottom of the water body. This feature makes the Dredge King an excellent choice for projects where water depth is a limiting factor. The Dredge King also comes with additional attachments that enhance its functionality. One such attachment is the clearing rake, which aids in removing vegetation or obstacles that may hinder the dredging process. Additionally, the dredger features outriggers for stability and ease of loading pontoons or other equipment. One of the key advantages of the Senwitech Dredge King is its multi-purpose nature. It can be utilized as both a cutter suction dredger and a bucket dredger. This versatility allows it to adapt to different dredging requirements, ensuring that it can handle a wide range of projects effectively. Whether it's deepening waterways, clearing sediment deposits, or creating new channels, the Senwitech Dredge King provides a reliable and efficient solution. With its autonomous water entry capability, powerful sludge pump, and multi-purpose functionality, it proves to be a valuable asset for various dredging applications. Equipped with a powerful suction system, the Trex Duke excels in suction dredging tasks. It can efficiently extract sediments, debris, and other materials from the waterbed, helping to maintain or deepen waterways. This feature makes it ideal for navigation channel maintenance, harbor dredging, and environmental cleanup projects. Additionally, the Trex Duke is capable of bucket dredging, which involves using a bucket or clamshell attachment to scoop and remove sediments from the water. This method is particularly useful for projects that require precise excavation or the removal of larger objects. Furthermore, the dredging boat is equipped for clearing works, making it capable of removing vegetation, floating debris, and obstacles that hinder navigation or disrupt the ecosystem. This feature enhances the boat's versatility and utility in maintaining the overall health and functionality of water bodies.
between Europe and Asia, facilitated the passage of more than 17,000 ships every year. However, the canal could only accommodate one-way traffic over a 35-kilometer stretch, resulting in significant waiting times for vessels traveling in opposite directions. To address this problem, a new parallel waterway was created to enable two-way traffic. Initially, it was estimated that the project would take 3 years to complete. However, Egyptian President Abdel Fattah el-Sisi aimed for a more ambitious timeline and set a goal to open the new Suez Canal within a year, an operation of historical proportions. The new Suez Canal is 35 kilometers long, 24 meters deep, and 400 meters wide, cutting straight through the desert. The construction process involved dividing the canal into 4 lots, with various dredging activities taking place simultaneously. The sand was removed from the canal bed to create a deeper and wider channel. In total, an astounding 200 million cubic meters of sand were moved during the construction, equivalent to about 80 times the volume of the Great Pyramid of Giza. The daily production reached 60,000 to 65,000 cubic meters, resulting in almost 400,000 cubic meters per week. The project office in Ismailia served as the nerve center, overseeing the logistics and equipment. A total of 28 units, including the largest number of dredges ever deployed on a single project, were involved in the construction, with nearly 1,800 people working on-site and 23 dredges operating simultaneously. Coordination was crucial. The Jan de Nul group deployed 7 cutter suction dredgers with a total installed diesel power of 134,720 kilowatts. These cutter suction dredgers played a vital role in the excavation and dredging process. Cutter suction dredgers are powerful vessels designed to remove sediment and debris from the seabed. They feature a large suction mouth equipped with a rotating cutter head. The cutter head, fitted with sharp blades, cuts through the soil and sediments at the seabed, breaking them into smaller pieces. As the cutter head rotates, the sediment is loosened and mixed with water. The dredger's powerful pumps then create a suction force, drawing the mixture of water and sediment into the vessel. Inside the dredger, the sediment settles in a hopper, while the excess water is discharged back into the sea. Trailing suction hopper dredgers are specialized vessels used for dredging operations in ports, waterways, and coastal areas. These ocean-going vessels are capable of collecting sand and silt from the seabed and transporting it over large distances. They play a crucial role in various construction and maintenance projects, including port development, land reclamation, coastal defense, and riverbank protection. The working principle of a trailing suction hopper dredger involves the use of 1 or 2 suction pipes that are equipped with drag heads at their ends. When the vessel reaches the dredging location, it reduces speed and lowers the suction pipes to the seabed. The drag heads then move slowly over the bed, collecting the sand and silt much like a giant vacuum cleaner. The mixture of sand and water, known as the dredged material, is pumped into the hopper of the dredging vessel. The vessel continues the dredging operation until it reaches its maximum hopper capacity. At this point, the dredging process is halted, and the vessel needs to discharge its load. Trailing suction hopper dredgers are equipped with advanced technologies and are capable of operating on projects all over the world. They offer the advantage of being self-sufficient and can transport the dredged material over long distances, making them versatile and efficient tools for various dredging operations. The discharge of the dredged material can be done in various ways depending on the specific project requirements. One method is known as rainbowing, which is used when the vessel can get close to the discharge location and the previously reclaimed sand body is above or almost above the water surface. In rainbowing, the sand is sprayed through a nozzle in the bow of the vessel, creating an arch through the air and depositing the material at the desired location. Another method of discharge involves pumping the sand ashore using floating or sunken pipelines. This approach is commonly used in land reclamation or coastal protection projects, where the sand is pumped through pipelines into the designated reclamation area. Alternatively, the sand can also be deposited through doors located in the bottom of the vessel. This requires precise maneuvering of the dredger above the designated location to ensure accurate deposition of the dredged material. The extension in the Sea of Monaco is a significant construction project aimed at reclaiming 15 acres of land from the sea. As part of this endeavor, various techniques and equipment are being utilized, including an excavator from the boats capable of reaching a depth of 25 meters. The primary objective of the excavator from the boats is to extract and remove polluted sediment from the seabed. The collected sediment contains traces of pollutants, particularly oil, which must be properly disposed of to ensure environmental sustainability. The process begins with the deployment of the excavator from a specially designed boat. This excavator is equipped with a powerful hydraulic arm and a bucket attachment capable of scooping large amounts of sediment. The boat is carefully positioned over the targeted area, and the excavator's arm is extended downwards to reach the seabed. The operator skillfully maneuvers the excavator's arm and bucket, ensuring precise placement and effective excavation. The bucket is lowered into the sediment, scooping up a substantial volume with each cycle. As the bucket is raised, excess water drains out through specially designed openings, leaving behind the polluted sediment. Once the bucket reaches the surface, it is emptied into a collection container on board the boat. The process is repeated multiple times until a significant amount of sediment has been excavated. The excavator's reach of 25 meters allows it to cover a considerable area during each operation, optimizing efficiency. To ensure the safe handling of the polluted sediment, strict protocols are followed. The collected material is carefully contained and transported to designated facilities for proper treatment and disposal. Specialized measures are implemented to prevent any accidental release of pollutants during the transportation process. In addition to the excavator from the boats, a special ship equipped with a cable excavator is also employed in areas with even greater depths. This cable excavator, similar in operation to the excavator from the boats, can reach larger depths and effectively extract sediment from the seabed. The excavator from the boats, along with the cable excavator, play crucial roles in the extension in the Sea of Monaco project. Through their combined efforts, approximately 50,000 cubic meters of polluted sediment have been successfully collected. This section may show the first you've seen an outfit content with letting a machine sink. It is an excavator working under the water. That's because this excavator is right where it's meant to be, digging trenches on the ocean floor. It's unclear exactly what kind of project this excavator is working on, be it pipeline, fiber, or something else, but judging by all the aquatic plant life all over the body of the machine, it has been a sea-dwelling digger for some time. And as far as the mechanics of this go, based on a few quick Google searches and a perusal of the comments of many interested people, that the excavator might have undergone modifications to adapt to its underwater environment. One possibility is that its engine has been removed entirely, as internal combustion engines are not suitable for underwater operation. Instead, the excavator may rely on hydraulic systems for power. These hydraulic systems are likely connected to pumps on the surface, which supply the excavator with hydraulic fluid to power its movements and operations. The Komatsu D155W is an exceptional piece of machinery designed to tackle challenging tasks in aquatic environments. As an underwater bulldozer, the D155W has proven its worth in various projects around the world, showcasing its capabilities and versatility. One notable project that showcased the D155W's capabilities was the restoration of a harbor damaged by a devastating tsunami in Iwate Prefecture, Japan. In March 2011, a powerful earthquake struck off the coast of Japan, triggering a massive tsunami that ravaged the northeastern coastline, including Iwate Prefecture. The tsunami's force caused significant damage to the region's infrastructure, including the local harbor. The task of rebuilding the harbor was daunting and required specialized equipment capable of operating in underwater conditions. Komatsu's D155W was deployed to the site to aid in the restoration efforts. This impressive machine possesses unique features that make it suitable for underwater operations. Equipped with a powerful engine and robust tracks, the D155W can navigate through waterlogged areas and exert considerable force to move debris and reshape the seabed. The D155W's hydraulic system enables precise control of its various attachments, such as a bulldozer blade or a clamshell bucket. This versatility allows it to handle a wide range of tasks, including dredging, excavating, and land reclamation. In the case of the Iwate Harbor restoration, the D155W played a crucial role in removing debris, clearing underwater obstructions, and reshaping the harbor basin. The machine's advanced engineering and ergonomic design also contribute to its efficiency and effectiveness. Operators have access to a comfortable and intuitive control system, allowing them to manipulate the machine with precision. The D155W's robust construction ensures durability in harsh underwater environments, providing reliability and minimizing downtime during critical operations. The Wilson Inlet Bar, opening in 2017, was a significant event managed by the Water Corporation in Australia. The purpose of opening the bar was primarily to prevent flooding in low-lying areas adjacent to the inlet. The specific timing and location of the opening followed an agreed protocol. To facilitate the bar opening, an excavator was employed to dredge a channel from the inlet to the ocean. The decision to open the bar was made when the inlet water level reached 1.27 meters AHD, Australian height datum, and was located approximately 100 meters from the Western Cliffs reference point. It is worth noting that this was the highest bar opening recorded since 1978. when the bar had an estimated elevation of 1.25 meters AHD at the time of opening. Once the bar was opened, approximately 27 gigaliters (GL) of water, which accounted for around 14% of the inlet's total volume, was discharged into the ocean within the first 24 hours. The volumetric flow rate was measured at 210 cubic meters per second on a Friday at 2 p.m. The high water level and strong flow effectively scoured the bar, widening it to approximately 150 meters. To document the event and its impact, a drone was used to capture aerial footage and imagery. Ash Ramsey, an individual from the Department of Water and Environmental Regulation in the Southwest region, operated the drone and documented the inlet's height, the bar opening, and the subsequent discharge into the ocean. The process of export cable shore landing is a crucial step in the installation of offshore wind farms. It involves bringing the export cable, which connects the wind turbines to the onshore power grid, from the offshore installation site to the beach, and then burying it beneath the seabed to protect it from external influences and ensure its stability. In the case of the Galloper Offshore Wind Farm, VBMS, a subsea services provider, executed the export cable shore landing using an innovative method that eliminated the need for divers, wet riggers, or support vessels. They employed a remotely controlled progressive buoyancy release system, which increased safety and efficiency by removing time-consuming interfaces. The cable laying process involved using a plow to bury the cable beneath the seabed. The plow, equipped with skids and a depressor, allowed for controlled cable deployment and burial. The cable entered the plow through a bell mouth and exited through the depressor, which was monitored for tension. Load cells were used to measure and maintain proper tension during the operation. After the plow reached the beach, the cable was released onto the seabed using an automated system that avoided the need for divers. The process of export cable shore landing is a crucial step in the installation of offshore wind farms. It involves bringing the export cable, which connects the wind turbines to the onshore power grid, from the offshore installation site to the beach, and then burying it beneath the seabed to protect it from external influences and ensure its stability. In the case of the Galloper Offshore Wind Farm, VBMS, a subsea services provider, executed the export cable shore landing using an innovative method that eliminated the need for divers, wet riggers, or support vessels. They employed a remotely controlled progressive buoyancy release system, which increased safety and efficiency by removing time-consuming interfaces. The cable laying process involved using a plow to bury the cable beneath the seabed. The plow, equipped with skids and a depressor, allowed for controlled cable deployment and burial. The cable entered the plow through a bell mouth and exited through the depressor, which was monitored for tension. Load cells were used to measure and maintain proper tension during the operation. After the plow reached the beach, the cable was released onto the seabed using an automated system that avoided the need for divers. After the plow reached the beach, the cable was released onto the seabed using an automated system that avoided the need for divers. This method ensured the safety of the operation. The next phase involved coordinating with the plow team and the vessel to begin burying the cable along its entire route. The cable, which spanned 43 kilometers in this case, needed to be buried to protect it from external influences and maintain its stability in the dynamic seabed environment. By utilizing the innovative progressive buoyancy release system and implementing efficient cable laying and burial techniques, VBMS successfully completed the export cable shore landing for the Galloper offshore wind farm. In a remarkable salvage operation, Cool Contractors successfully retrieved a 6,000-ton floating dry dock that had broken loose from its mooring at Orsund Dry Docks premises in Landskrona, Sweden. The dock, measuring 165 by 35 meters, drifted towards the Bay of Lundakra and eventually stranded in a sensitive Natura 2000 area due to high seawater levels. The unique challenge posed by this salvage operation was the shallow water depth of only 0.5 meters and the need to protect the surrounding nature area. Cool Contractors devised an unconventional method to refloat the dock, employing out-of-the-box thinking that would ultimately lead to success. To prepare for the salvage operation, Cool Contractors embarked on an extensive construction project. They began by creating an artificial basin around the stranded dock using 200 crane mats and 175 steel beams. This impressive basin had an area spanning approximately 28,000 square meters, providing ample space for the dock to be maneuvered and refloated. In addition to the basin, a 1.8-kilometer long channel was painstakingly dug to facilitate the movement of the dock. This channel reached a depth of 2 meters, ensuring that the dock would have a clear pathway to navigate once it was refloated. Furthermore, in order to safely tow the dock back to deeper waters, another channel was built, extending approximately 2 kilometers. This additional channel allowed the dock to be transported to a location with more favorable conditions for towing. To bring the dock back to a floating state, the basin was filled with water. This water was necessary to provide buoyancy and support the weight of the dock. The process involved gradually filling the basin, allowing the dock to rise and float once again. During the salvage operation, the region experienced cold weather conditions, including the presence of ice. To address this challenge, gas burners were employed to melt the ice that had formed within the tanks of the dock. By melting the ice, the dock's overall weight was reduced, making it easier to refloat and tow. Once the basin was ready, the dock was refloated by filling it with around 60 million liters of water. Using winches, anchors, and cranes, the dock was repositioned and oriented towards the newly formed channel. A deep gully was created within the basin to ensure that the dock would remain afloat once the water level was lowered.
The situation is that we're still filling up and the water level is increasing.
With the dock now floating and in position, the water level in the basin was gradually lowered back to sea level. This allowed the dock to begin its journey through the channel towards open waters. The success of this phase depended on favorable weather and tidal conditions, which required careful monitoring and coordination. Throughout the entire salvage operation, Cool Contractors maintained a strong commitment to environmental preservation. They took extensive measures to minimize any negative impact on the surrounding nature area, adhering to strict protocols and regulations. With the dock safely returned, efforts were made to restore and rehabilitate the environment to its original state, ensuring the protection of the sensitive Natura 2000 area. Finally, with optimal conditions, the dock made its way through the channel, assisted by tugboats, until it reached its original location at Orson Dry Docks. The precision and care exercised by Quay contractors ensured a safe and successful return for the dock, captivating the attention of spectators who witnessed this extraordinary transportation process. The salvage of the 6,000-ton dry dock by Quay contractors showcases their ingenuity, expertise, and dedication to overcoming complex challenges. Through their innovative thinking and meticulous execution, they successfully refloated and returned the dock to its rightful place, demonstrating their commitment to both environmental preservation and operational excellence.
In an impressive feat of construction, Ryan Rude Construction recently undertook the pouring process for a massive 82-foot grain bin pad, utilizing the cutting-edge Lura lightning strike roller screed. The first step in this endeavor involved creating a bolt guide, which would serve as a template for the bolt pattern necessary to secure the grain bin. The Lura lightning strike roller screed played a pivotal role in the pouring process. Its advanced design and functionality allowed for smooth and consistent concrete placement across the entire 82-foot span. The screed's lightning-fast operation significantly reduced the time and labor required for the project while maintaining exceptional quality. With a 41-foot radius, the grain bin pad posed additional challenges in terms of achieving a uniform surface. However, the Lura lightning strike roller screed effortlessly navigated the curved contours, resulting in a perfectly level and aesthetically pleasing finish. The drive unit of the lightning strike roller screed contains a motor that powers the rotation of the tube. The operator would start the screed and guide it along the surface of the freshly poured concrete. As the lightning strike roller screed moves forward, the spinning tube levels and distributes the concrete across the surface. The high-speed rotation of the tube helps to remove excess concrete, fill low spots, and create a smooth, flat finish. This section shows the construction process of the dome. Once the design is accepted and approved, construction work commences on the site. Excavation takes place for the foundation and tunnels. Different methods are employed to construct the tunnels, including the use of precast elements. Precasting allows for quicker tunnel construction, meeting deliverable dates consistently and aiding the customer in becoming operational. Airform fabrication is a vital step in the dome construction process. The airform, a specially designed fabric membrane, is carefully attached to the dome's ring beam. Once the airform is in place, the inflation process begins. As air is pumped into the structure, the dome rapidly takes shape, causing an impressive transformation of the surrounding landscape. This inflated airform serves as the starting point for the construction of the dome. From this stage onward, the project is built from the inside out. A layer of polyurethane foam is applied to its underside. The foam layer acts as a framework for the installation of rebar. It provides insulation and structural support, creating a solid base for the subsequent layers of the construction. The polyurethane foam adheres to the airform and expands, filling any gaps and ensuring a smooth surface for the rebar installation. Once the rebar framework is in place, the shotcrete application begins. Shotcrete is a mixture of concrete, sand, aggregate, and sometimes additives, which is sprayed onto the rebar and foam layer. It is applied in layers, starting with thin initial layers that gradually increase in depth as the structure gains rigidity and strength. The shotcrete fully encapsulates the rebar and forms the solid outer shell of the dome. Throughout the construction process, the combination of the polyurethane foam, rebar, and shotcrete creates a durable and resilient structure. The foam provides insulation, the rebar reinforces the dome, and the shotcrete ensures a strong and long-lasting exterior. The conical concrete pour is a specialized technique used in the construction of grain silos and other structures with conical shapes. It involves pouring concrete on a sloped surface while ensuring that the concrete is distributed evenly and does not accumulate at the bottom of the structure. The process is made easier and more efficient with the use of the Lura Lightning Strike roller screed. The Lura roller screed is a lightweight yet durable tool designed specifically for concrete pours on slopes. In this case, it has 38-degree slope, 58 feet across, 34 feet from bottom to top. The key to a successful conical pour is the utilization of the center pin pivot at the bottom of the structure. Rakers, or workers, move around the cone on a slope to prevent the pooling of excess concrete at the bottom. At the top, a screed pipe or rail is used in conjunction with the center pin pivot to maintain the correct height of concrete throughout the pour. This innovative design significantly reduces the time required for conical pours. The Lura screed is easy to set up and use. For circular pours, a base plate is first set into the floor before pouring. The screed is then connected to a shaft inserted into the base plate, and a center pin is placed into the shaft. This setup allows for one-person circular screeding, providing convenience and efficiency. Once the pour is complete, the screed, pin, and shaft are removed, and a small amount of concrete is filled in. The base plate remains in place under the concrete, ensuring stability and structural integrity. When it comes to larger circular pours, the Lura screed offers a method to strike pours larger than 50 feet without deflection. The process involves measuring outwards from the center pin, pounding in rebar or wood stakes around the measured distance, and using a string or laser level to establish the appropriate height for the yoke system. The Lura screed provides several advantages for contractors. It enables effortless circular pours, even on larger structures, with the use of the center pivot and form runners. Contractors have reported being able to pour 30-foot bin floors with just a two-man crew. The lightweight design of the screed and its easy cleanup further contribute to its user-friendly nature. The Lura screed can be set up or cleaned up by a single person in 5 minutes or less. The world's first open-topped cable car, known as Cabrio, has revolutionized the concept of aerial transportation. Developed by Doppelmayr, one of the leading manufacturers of cable cars and ropeways, Cabrio offers passengers a unique and exhilarating experience as they ascend to great heights while enjoying panoramic views. The construction of this innovative cable car took place at the picturesque location of Stanserhorn, showcasing the engineering prowess and vision of Doppelmayr. The construction process of Cabrio at Stanserhorn began with meticulous planning and design. Doppelmayr engineers worked closely with architects and experts to ensure that the cable car would blend seamlessly into the surrounding natural landscape. The goal was to create an extraordinary experience for passengers, allowing them to connect with nature while being transported to the mountain summit. The construction team started by preparing the ground at the base station where the cable car would originate. A solid foundation was laid, ensuring stability and safety throughout the entire system. Next, the support towers were erected, each strategically placed to provide maximum stability and optimize the cable car's trajectory. The heart of the Cabrio cable car is the spacious and modern cabin. It was meticulously designed to offer unparalleled views and comfort to passengers. The construction team meticulously assembled the cabin, carefully installing large glass windows and ensuring that every detail, from seating arrangements to safety features, was perfected. The most striking feature of Cabrio is its open-top design. This innovation provides an unforgettable experience, allowing passengers to feel the refreshing mountain breeze and observe the stunning surroundings in an immersive and unrestricted manner. The engineering team ensured that the open-top structure was not only aesthetically pleasing, but also met stringent safety standards. Once the base station, support towers, and cabin were ready, the construction team focused on installing the cable system. Specialized machinery was used to meticulously thread the steel cables through the support towers, ensuring they were precisely tensioned and aligned. These cables form the backbone of the cable car system, ensuring the safe and smooth operation of Cabrio. After the installation of the cable system, rigorous testing and inspections were conducted to ensure the highest safety standards were met. Every aspect of the cable car's functionality, from its propulsion system to emergency protocols, was thoroughly evaluated and validated. Finally, after months of careful construction and testing, Cabrio was ready to welcome its first passengers. The cable car has since become a symbol of innovation and adventure, attracting visitors from all around the world who seek to experience the thrill of riding in an open-topped cable car while marveling at the breathtaking views of Stanserhorn. This section shows the construction process of two heavy-duty cableways with extreme load capacities by Garaventa, Austria. These cableways were designed to handle weights of 30 and 40 tons, respectively. The primary objective was to facilitate the construction of the KLL power plants by providing a reliable means of transporting materials to the challenging mountainous terrain. The production of the cableways took place in Garaventa's specialized facilities in Goldau and Quad. The construction involved the use of hundreds of tons of high-quality steel. The fabrication process required precision and attention to detail to ensure the integrity and strength of the cableway components. The construction of the heavy-duty cableways presented several challenges. Firstly, the existing cableway infrastructure was inadequate to handle the enormous weight of the construction materials. Therefore, Garaventa had to design and construct new cableways specifically tailored to meet the project's requirements. The engineers and designers had to consider factors such as load capacity, safety, and adherence to industry standards, including the CEN cableway norms. Additionally, the project faced stringent time constraints. The construction needed to be completed within tight schedules to meet the overall project timeline. Therefore, Garaventa had to adopt a parallel development and construction approach, enabling different components of the cableways to be constructed simultaneously. This required effective coordination and management to ensure the seamless integration of the various construction activities. To connect the two cableways, a 3 kilometers long access tunnel was constructed. This tunnel served as a crucial link, allowing seamless movement of materials and personnel between the cableways. The construction of the tunnel required meticulous planning and engineering expertise to ensure its stability and functionality. Another significant challenge was the unique terrain of the construction sites. The mountainous region posed difficulties in terms of accessibility and stability. The construction team had to overcome these obstacles by implementing innovative engineering solutions. Practically all the components of the cableways had to be newly designed to accommodate the demanding environment. The production of the cableways took place in Garaventa's specialized facilities in Goldau and Quad. The construction involved the use of hundreds of tons of high-quality steel. The fabrication process required precision and attention to detail to ensure the integrity and strength of the cableway components. Installing the cableways in the challenging terrain required a dedicated team of Garaventa technicians and workers. They had to work in difficult conditions and, at times, stay overnight at the construction sites. The logistics of transporting the cables were complex. Pier Special Transport, a specialized transport company, was responsible for delivering the cables to the valley station of the first cableway. Approximately 1,000 tons of cables were transported, including 8 support cables with a diameter of 90 millimeters and 4 traction cables. One of the remarkable achievements of the construction process was the development of new linear cable pulling machines. These machines, coupled with Garaventa's years of experience in handling cables, enabled the successful installation of the cables within a remarkably short time frame. In just 8 weeks, the 8 support cables and 4 traction cables were pulled to the first cableway and through the access tunnel to the second cableway. This logistical feat demonstrated the ingenuity and expertise of the Garaventa team. The assembly and testing phase of the cableways required meticulous attention to detail and adherence to strict safety standards. The vehicles were precisely positioned on the support cables to ensure optimum performance and safety. Additionally, the cableways were subjected to comprehensive testing to meet the regulatory requirements. These tests included brake tests with extreme loads of up to 40 and 30 tons, assessing the compliance of the support seats with the regulations, and verifying the functionality of all the load-bearing systems. Safety remained a top priority throughout the construction process. Measures were implemented to ensure the safe evacuation of individuals from stranded vehicles. For years, China has been undertaking ambitious projects that involve the removal of mountains to create flat land for development. This practice, known as mountain relocation, has gained momentum in the past decade as China faces challenges in accommodating its growing population and expanding cities. Approximately 1/5 of China's population resides in mountainous areas, and with limited land availability for development, local officials have turned to flattening mountains to create new plains. The motivation behind these projects is twofold. Firstly, local authorities believe that by destroying mountains and selling or leasing the newly acquired land, they can generate substantial revenue in the form of billions of yuan. This influx of funds can help alleviate pressure on agricultural or culturally significant land elsewhere, allowing for sustainable development in those areas. Secondly, the creation of flat land provides more space for urban expansion, accommodating the needs of China's rapidly growing cities and their swelling populations. One notable example of this mountain relocation practice is the planned development of Lanzhou's new district. This project, spearheaded by one of China's largest construction companies led by Yang Jia, aims to flatten 700 mountains at a cost of £2.2 billion. The resulting 500 square miles, 130,000 hectares of new land is expected to boost the region's gross domestic product to £27 billion by 2030 and has already attracted nearly £7 billion in corporate investment. However, these endeavors have not been without their critics and concerns. Lanzhou, the city where the new district is planned, already faces significant environmental challenges, including severe air pollution and pollution in the Yellow River, which runs through the city. These issues have prompted skepticism about the wisdom of such a large-scale project in an area already burdened with environmental problems. Mountain relocation projects have been associated with various negative environmental impacts. The creation of new land often leads to air and water pollution, soil erosion, and geological risks such as subsidence. These projects also result in the destruction of forests and agricultural land, posing threats to wildlife and plant biodiversity. In the case of Lanzhou, it is projected that the earth-moving project alone could increase soil erosion by 10% and raise dust particles in the air by 49%, exacerbating the city's existing air pollution issues. It is essential to strike a balance between economic development and environmental sustainability. While mountain relocation projects may offer short-term economic benefits, they must be accompanied by comprehensive environmental impact assessments and robust mitigation measures to minimize harm to ecosystems and human health. Additionally, exploring alternative approaches to urban development, such as vertical construction or repurposing existing infrastructure, could alleviate the need for extensive land flattening. China's mountain relocation projects exemplify the country's drive for rapid development and urbanization. However, the long-term consequences of these projects on the environment and public health cannot be overlooked. As China moves forward, it is crucial to adopt a holistic approach that prioritizes sustainable development, balances economic growth with environmental protection, and considers the well-being of both present and future generations. The fabrication process of the Elizabeth Quay Bridge involved Perth-based steel manufacturers who were selected to build the structural steelwork for the bridge's arches and deck. Close collaboration between the design team, contractor, and fabricator was essential to meet the required construction tolerances and achieve both structural adequacy and aesthetic aspirations. The arches were fabricated off-site in 3 different lengths, while the deck was fabricated in 12 different lengths. The modules were built adjacent to each other in the manufacturer's yard to ensure that construction tolerances could be achieved. The erection process of the Elizabeth Quay Bridge involved the careful installation of the prefabricated arches and deck components. Specialized cranes and equipment were utilized to ensure the safe and accurate placement of these elements. The prefabricated arches were delivered to the construction site in 3 parts. These sections were aligned and welded together during the installation process. The standing of the 2 arches was carried out in a single operation that lasted approximately 2 hours. To secure the arches in place, hinges were utilized at the base connections, and a central crane was employed. Importantly, the arches were never fully lifted off the ground during the erection process. a central strut was trailed along a temporary track during the crane lift, allowing the arch to be securely locked into position. This innovative approach not only ensured the stability and safety of the structure, but also enabled the site to be quickly and safely evacuated if necessary. The planning and constructability assessments conducted beforehand were crucial in achieving precise positioning, with the arches erected within a remarkable 2 millimeter deviation from the documented position. The deck components were brought to the site in segments, which were then placed onto a temporary support system and welded together. The cables from the arches were attached to the deck, and the abutments were installed. As the temporary support system was gradually lowered below the deck box, the weight of the deck was transferred to the cables. Throughout the erection process, close attention was given to ensure the alignment and coordination of the arches, deck, cables, and support systems. The expertise and coordination of the construction team were essential in achieving a precise and seamless assembly of the bridge components. The erection process of the Elizabeth Quay Bridge required meticulous planning, skilled execution, and the utilization of specialized equipment. The careful alignment and connection of the arches and deck, along with the strategic use of temporary support systems and cranes, allowed for the successful construction of the bridge, meeting the structural requirements and design vision of the project. The bridge completes a waterfront redevelopment that has transformed the river foreshore into a busy promenade, lined with bars, restaurants, and public spaces, and is set to be surrounded by a vibrant mix of offices, apartment buildings, hotels, and shops. The bridge promotes continuous movement around the quay and links the island to a popular recreational circuit around the Swan River. Visitors to the precinct can now walk, run, and cycle across the bridge, enjoying spectacular panoramic views.